Hi my dear students, hope you all are doing absolutely good. I welcome you all to this amazing YouTube channel of Brilliant Katha. So guys, today is a big day. You know why? We are going to start JEE Mains and Advanced series on our YouTube channel. So you guys, you know now, like this particular crash course is on high demand. In this crash course, we'll be completing complete 11th and 12th topics on one single shot. Each topic will be covered in one single shot. So friends, like if at all, if you are feeling like something, no, I can't do this particular thing, or no, I'm fed up with all these things. My dear friends, just believe me, by completing of this particular series, I will guarantee you, I personally guarantee you and I promise you that you'll be getting a good confidence on all our complete mathematics grade 11th and 12th topics. So the sequence of today's flow will be like, in today's session we'll be starting the first topic, that is basic mathematics. In this basic mathematics we'll be covering number system, number 2 basic inequalities, polynomials, modulus and logarithms. Modulus means complete, like equality modulus, inequality modulus, logarithm, inequalities, equality. Everything will be discussed in today's session. Friends, shall we start? Good. So natural numbers. All counting numbers in mathematics are called as natural numbers. Set of natural numbers are denoted with capital N, and N takes a set from 1, 2, 3, 4, 5 and so on. It is an infinite set. There is nothing to discuss about much. Then prime number. All the prime numbers, all the natural numbers which are divisible by 1 and itself only are called prime numbers. Example, we have 2, 3, 5, 7, 11, 13 and so on. Another interesting thing regarding prime numbers is, if you see friends, like 2 is the smallest prime number that we have and 2 is the only even prime that we have. Smallest odd prime number is 3. 1 is neither a prime nor a composite number. But for now, like 1 is not a prime number. Every prime number greater than 3 is always of the form 6k plus or minus 1. Oh, very, very important, friends. Very important. And one more thing is, but the converse need not to be true. Every prime number greater than 3 is always of the form 6k plus or minus 1. But converse need not to be true. Primality test. Like to check a given number whether it is prime or not, what we do? In general, we just suppose, like, if to check whether 16 is a prime or not, from 2 to root 16, the value of root 16 is 4. Now from 2 to 4, all the set of natural numbers whatever we have, 2, 3, 4, we'll divide this particular number with a 2, 3, 4. If it is divisible, then it is not prime. If it is not divisible from 2 to root n, then such number is said to be prime. So this is like a primality test. To check whether any given number n is a prime or not, divide the number from 2 to the integer part of root n. If it is divisible, then it is not prime, else it's not prime. Clear? Now, composite number. The numbers except 1 and which are not prime are called composite numbers, we say. Example, 4, 6, 8. In general words, we say composite numbers are natural numbers which has more than 2 factors, Smallest composite number is 4. Smallest odd composite number is 9. 1 is neither a composite number nor a prime number. Composite number can be expressed as exponent of primes. That is what we say fundamental theorem of arithmetic in grade 10 that we have discussed. In grade 10, like, we have a beautiful theorem called fundamental theorem of arithmetic, and that states that every composite number can be expressed as the product of primes. And this factorization is unique except the order of the prime factors occurs. Good. Co-prime numbers. Simple thing. Co-prime numbers means, like, it's not like co-primes need not to be primes. Co-primes means a pair of numbers making sure that their common factor is only 1. So that is, 2 natural numbers are said to be co-prime whose HCF is 1. 1, 3, HCF of 1, 3 is 1, HCF of 3, 5 is, like, if you observe one particular thing, the common factor of these two pair numbers is only 1, 3, 5 is only 1, 25, 33 is only 1. 2 prime numbers are always co-prime, but the converse need not to be true. 2 consecutive natural numbers are always co-prime. Next, twin primes, another interesting. Here, coming to co-primes, the numbers need not to be prime, but twin primes, two prime numbers two prime numbers, if their difference is 2, then we say such primes are said to be twin primes. Example 3, 5, 5, 7, 11, 13, etc. Whole numbers we know now, like if you are going to include 0 to the natural numbers, then such set of numbers are called whole numbers. Whole numbers are denoted by capital W. Integers, all the set of positive numbers, negative numbers, 0 together we say integers, or called set of integers. Integers are generally denoted by either capital I or capital Z. I plus or Z plus, we say positive integers. I minus or Z minus, negative integers. I plus or Z plus, positive integers then means like set of natural numbers only. Negative integers means I minus or Z minus, then we say only set of negative integers we say. If you say non-negative integers, see, just try to understand the difference between positive integers and non-negative integers. In the difference between these two, here we are going to include 0. So set of non-negative integers means 0 added to all these positive integers, 0 included in it. Non-positive, 0 included to non-negative, that's it. So even integers which are divisible by 2 are called even integers. So 0 plus or minus 2 plus or minus 4 plus or minus 6 and so on. In general, every even number is always represented of the form 2n, comma, n belongs to capital I it is. Odd integers, integers which are not divisible by 2 are called odd integers. Example, plus or minus 1, plus or minus 3, it's generally represented by either 2n minus 1 or 2n plus 1, n belongs to capital I. A rational number, any number which can be expressed in the form of p by q, where p comma q are integers, where q shouldn't be 0. As you know, set of rational numbers are denoted by capital Q. Friends, in decimal representation, any number which is either terminating or non-terminating recurring can be expressed in the form of p by q. That means, so in decimal notation, all the terminating numbers as well as non-terminating recurring numbers, non-terminating repeating numbers will be our rational numbers. Irrational numbers, any real number which is not rational we say, in simple words, like, or any number which can't be expressed in the form of p by q, where p comma q are integers, then such numbers are said to be irrational numbers. See, root 2, root 3, pi, root 310 and so on. E will be like Euler's number we say, or Napier's constant, anything is fine. Numbers which are not rational is called a rational number. Set of rational numbers is represented by q dash or q complement we say, anything. In decimal notation, non-terminating, non-recurring numbers are said to be irrational numbers, because these numbers can't be expressed in the form of p by q. Example, see na, like suppose x is equals to 1.231217 and so on. Such numbers are said to be non-terminating, non-recurring. Hence this can't be expressed in the form of p by q, hence it is called as an irrational number. Next, real number, the set of rational numbers, irrational numbers we say, like the union of rational and irrational. Simple words, R is equals to union of q and q dash, the complete set of rational and irrational numbers in the set of real numbers, and it is denoted by capital R. Very important, friends, that is like we say R is equals to minus infinity to plus infinity. So all the set of numbers, irrational we take, rational, every number comes under real numbers. And one more thing, real number line, very important, friends. A line on which all the real numbers can be shown is called a real number line. And this is how real number line will be there. In this particular real number, in every number, whether it is rational or irrational, any number, decimal, every number will be represented on this number line. That is what we say real number line. Or we say just simply number line. Some basic things. Integers are real numbers. Integers are rational numbers, but conversely not to be true. Yeah. Because like see, 2 is a rational number. 2 is a rational number as well as an integer. But 3 by 4 is a rational number, but it is not an integer. Negative of an irrational number is always an irrational again. Sum or difference of rational number and an irrational number is always an irrational number. Example, see, 2 plus root 3, 3 minus root 5. The product or quotient of a non-zero rational number and an irrational number will always be an irrational number. And one more thing, A belongs to Q and B does not belongs to Q, then AB is equals to rational number only if A is equals to 0. Because the product of a rational and an irrational will be always irrational unless and until the rational term is 0. Sum, difference, product and quotient of any two rational numbers need not to be rational, because see, if I take root 2, I am subtracting it from root 2, I got a rational. There exist infinitely many rationals and irrationals between two integers or between two real numbers. Suppose if I take 2 and 2.1, there exists infinite number of rational numbers as well as irrational numbers from 2 to 2.1. In general, like the pattern of squares, cubes, we need to know, like from 1 to 20, it's minimum necessity, square of a number, cube of a number, square root, cube root, like 16 and so on. Algebraic formulae, in general we come across a plus b whole square, a minus b whole square, a square minus b square, a plus b whole cube, a minus b whole cube, a cube plus b cube, a cube minus b cube. Make sure that you are thorough. If you are, unless and until we are thorough with this, like we are not able to go good in factorization. So that's the reason. Next, a plus b plus c whole square is equals to one most important thing I would like to tell you in this. A plus b plus c whole square, as you know, like a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Yeah, if you are going to take like 2abc common in this, then you will be getting 2abc of 1 by a plus 1 by b plus 1 by c. This plays a very important role, very important role. Like a square plus b square plus c square minus ab minus bc minus ca will be, suppose if you are going to multiply and divide with 2, so 2a square plus 2b square plus 2c square minus 2ab minus 2bc minus 2ca. Now that becomes, friends, half of 2a square, like here we have 2a square plus a square. I'm just taking one a square from here, one b square from here and minus 2ab. That is a square plus b square minus 2ab. The leftover b square, 1c square, b square plus c square with minus 2bc. Leftover a square, leftover c square and minus 2ca. A square plus c square minus 2ca. This can be written as half a square plus b square plus minus 2ab. That is a minus b whole square plus b minus c whole square plus c minus a whole square. Most important thing, like we should, it's very important even expressing this in this particular form. So from that, the previous thing, whatever we have discussed, they can be carried out here. A cube plus b cube plus c cube minus 3abc can actually be written as a plus b plus c times a square plus b square plus c square minus ab minus bc minus ca. So that means this particular part can be written as we already seen, half of a minus b whole square plus b minus c whole square plus c minus c whole square. One important thing I would like to derive in this thing, like if this particular part is 0, that means like if a cube plus b cube plus c cube minus 3abc is 0, then I can either this 0 or this particular part 0. That means either a plus b plus c is equals to 0 or this particular part, that is either a square plus b square plus c square minus ab minus bc minus ca will be equals to 0. But already we know now this particular thing is nothing but half of a minus b whole square plus b minus c whole square plus c minus a whole square is equals to 0. That implies a minus b whole square plus b minus c whole square plus c minus a whole square is equals to 0. Friends, here we know one particular thing. A comma b comma c are three real numbers. The sum of the squares of three real numbers will be 0. Very important. If the sum of the squares of three real numbers is 0, that means if I take, suppose if x comma y are any two real numbers, if I say x square plus y square is equals to 0, this happens only in one case, that is x is equals to y is equals to 0. In the same way, if I take x square plus y square plus z square is equals to 0, then I take x, y, z must be equal to 0. Here in the same way, like a minus b 0, b minus c 0, c minus c. That implies, friends, that implies a is equals to b equals to c. These two things are very important. Whenever the expression a cube plus b cube plus c cube minus 3abc is equals to 0, then there can happen either a plus b plus c equals to 0 or a equals to b equals to c. Next, yes, one more thing, like we come across this particular factorization in most of the cases, like a to the power 4 plus a square plus 1. This can be written as, friends, a power 4 plus a square can be written as 2a square minus a square plus 1. Hope you understood now. 1a square can be written as 2a square minus a square. Now this is like of the form a square whole square plus 2 times a square into 1 plus 1 square minus a square. So this is clearly of the form a plus b whole square. Hence a square plus 1 whole square minus a square is something square, x square minus y square. This particular expression can be like a square plus 1 minus a into a square plus 1 plus a. So hence this can easily be factorized. Whenever you come across this expression, please make sure that you remember this. A to the power 4 plus a square plus 1 is equals to 1 plus a square into 1 minus a plus a square. One question, one beautiful question based on the same thing, like whatever we have discussed. Question number 1. Friends, very simple. They have given this particular thing. This was asked in like case set. If a square plus b square plus c square minus ab minus if a square plus b square plus c square minus ab minus bc minus ca is less than or equals to 0, where a, b, c are non-zero, then find the value of a plus b whole divided by c. Just basic common sense, See, already we have seen this expression. Now, a square plus b square plus c square minus ab minus bc minus ca. This is nothing but half of a minus b whole square plus b minus c whole square plus c minus a whole square. This is less than or equals to 0. Friends, basic thing. Can the sum of the squares of 3 positive numbers, can it be less than 0? No. So it can only be equals to 0. But when will it be equals to 0? As we already seen, if a equals to b equals to c. That means now they are asking us to get the value of a plus b whole divided by c. As a equals to b equals to c, then we can take a in place of b again a, in place of c again a. That becomes 2a whole divided by a. Answer is 2. Very simple now. Good. Another another interesting question, a basic question. For any real numbers ABC, find the smallest value of the expression 3a square plus 27b square plus 5c square minus 18ab minus 30c plus 237. I'll just give you 2 seconds to think about it. Friends, I see the approach is only one particular thing, friends. Like, make sure that whatever the funda, the basic funda which is being required to each and everything, I'm just providing it, and based on that we are going with each and every concept. So now coming to the question, 3a square plus 27b square plus 5c square minus 18ab minus 30c plus 237. This will be like, just do understand, friends, like, see, we can take 3 common from these. 3 of a square plus 9b square minus 6ab. Now from these two, I can just take 5 common. So c square minus 6c plus 237 as it is. 237 as it is. Now this becomes 3 of a square plus this becomes 3b whole square minus a times of 2 times of a times of 3b. Completing square method in grade 10 already we know na. C square minus 6c. This can be written as 2 times c into 3. So I'm just adding 3 square and subtracting 3 square plus 237. That becomes, friends, 3 times of a plus a minus 3b whole square plus 5 times of this becomes C minus 3 whole square. We have minus 9 plus 237. So 3 times of A minus 3B whole square plus 5 times of C minus 3 whole square. 5 9s are 45. 237 minus 45. 237 minus 45 plus 237 minus 45. That becomes 23 minus 4, 19. So that becomes 192. So friends, finally we can even just express this as 3 times A minus 3B whole square plus 5 times C minus 3 whole square plus 192. Now I would like to tell you one thing, one beautiful and interesting thing here is they are asking us to smallest value. That means minimum of this, minimum. Minimum means, friends, we have expressed this term to this form. To get the minimum of this particular expression, this is already a constant. This can't be either minimized or maximized. This is square of an expression. What will be the minimum of this? 0. Minimum of this particular expression is 0. What about this? Minimum of this particular expression is also 0. So coming to the minimum, that is the smallest value of this particular expression, that will be 192. Hope you understood, guys. Very simple fundamental. Very, very, very simple. Only we have used basic algebraic identities part. Coming to the next one, another interesting one, a cube plus b cube. They have given another a cube, a particular data they have given. A cube plus b cube plus 3ab is equals to 1. Now they are asking us to get the value of, then which of the following can be true? One option a plus b 1, second option a equals to b equals to minus 1, third option a 3ab. Okay, fine, TK. Let's see friends, basic rearrangements of this thing. A cube plus b cube minus 1 can be equals to minus 3ab. Shuffling 1 to the left hand side, swapping 3ab to the right hand side. Now a cube plus b cube plus minus 1 whole cube is equals to 3 times a times b times minus 1. Friends, have you ever seen this expression? If a cube plus b cube plus c cube is equals to 3abc, basic fundamental that we have here is either a plus b plus c. That means in place of c we have a plus b plus c. In place of c here we have minus 1 equals to 0, or a equals to b equals to minus 1. That means, friends, a plus b value can be either 1 or a equals to b equals to minus 1. Hope you understood now. Very good. Friends, the expression square root of 12 plus 6 root 3 plus 12 minus 6 root 3 can simplify to. Very basic fundamental thing again. See, just how can we express this? 12, see, just a common sense, like 6 root 3 can be expressed as 2 times 3 times root 3. Now, can we express this 12 in terms of like 3 and root 3? Yeah, of course. 12 can be expressed as 3 square plus root 3 square. See, this becomes 3 plus root 3 whole square. 3 plus root 3 whole square. Square root of 3 plus root 3 whole square. This will be equals to 3 plus root 3. In the same way, this can be written as 3 minus root 3. Now, if you are going to add these two, 3 plus root 3 plus 3 minus root 3, negative root 3 plus root 3 gets cancelled. 3 plus 3 will be 6. There will be some students who even can express this 12 minus 6 root 3 as root 3 minus 3 whole square. Square root of root 3 minus 3 whole square. But friends, you know now, one most important thing, because square root of a square is always equals to mod a, because whatever the value that comes out of square root should be always positive. So you can't express this as root 3 minus 3, because root 3 value is less than 3. Hence, this will be equals to 3 minus root 3. Hope you understood now. Good. Yes, we are done with the basic questions. Next, coming to polynomials, like let's try to recollect some things from polynomials too. Remainder theorem we know na, like if p of x is any polynomial, friends, if p of x is any polynomial and if it is divided by a linear factor x minus a linear polynomial x minus a, then the remainder is p of a. Very simple. So if p of x is be any polynomial of degree greater than or equals to 1 and a be any real number, if p of x is divided by x minus a, then the remainder is p of a. We'll go with a beautiful example, a simple example, x square minus 3x plus 4. Now we are going to divide this, particular polynomial with something like x minus 1. Okay, we are going to divide with, by remainder theorem, if you are going to divide p of x by x minus 1, the remainder will be p of 1. Just equate this to 0, whatever the corresponding x value you get, you just substitute in the polynomial. So that is p of 1 is equals to 1 square plus 3 into 1 plus 4. So that is 1 plus 3 plus 4, you get 8. That's it. Next, factor theorem. Oh, sorry. One small question. Determine the remainder where when the polynomial p of x is divided by x minus 1. Same na? Like we have p of x. It is divided by x minus 1. That means remainder will be p of 1. Very simple it is. I hope you will do it on your own. Okay? Good. Very good. Very good. Very good. Another question. Find the value of a if x minus a is a factor of this. Say friends, like what do you mean by the factor? Huh? If p of x is divided by x minus a, the remainder is p of a. Imagine that this remainder is found to be 0. That is, if p of a is 0, then that g of x, whatever the dividend polynomial that we have, divisor polynomial that we have, x minus a, that will be the factor of the dividend polynomial. That means, so if x minus a is a factor of this, that means here p of a must be equated to 0. Just put a in place of x, a cube, minus a square into a, again a cube, plus a plus 2 is equals to 0. Hence the value of a is minus 2. Simple na? Good thing. Friends, p of x is a polynomial of degree 5 with the leading coefficient unity such that p of 1 is equals to 1, p of 2 is equals to 4. Oh, very simple, very beautiful question. This was asked in KVPY. P of x is a polynomial of degree 5 with the leading coefficient 1. That means the highest power, x to the power 5 coefficient has to be 1. They have given some basic things like some requirements. P of 1 they have given, P of 2 4 they have given, P of 3 9 they have given, P of 4 16 they have given, P of 5 25, and they are asking us to get P of 6. See, one basic thing, one important thing, like if a student come across this particular question, the moment he sees the question, he finds like all these of symmetry na, p of 1 1, p of 2 4, p of 3 9, p of 5 25. The moment he sees the question p of 6 he thinks about 36. Immediately he'll be marking 36. But no, I'll tell you why. Because see friends, if p of 6 could have been 36, then what will be polynomial? It will be of x square na. But we need a polynomial which is of degree 5. If p of x is equals to x square, that won't be our polynomial then. That won't be 5th degree polynomial. So p of x is equals to, friends, x square. But that one thing is true. P of x is equals to x square is true for x equals to 1, x equals to 2, x equals to 3, x equals to 4, x equals to 5. Now, do you agree? P of x is equals to x square is true for x1, x2, x3, x4, x5. Do you agree? Because based on the given statements that we can just adopt it. Just simple fundamental by factor theorem. See, already we have seen this. Therefore, p of x minus x square will be 0 now. P of x is equals to x square is 1 point. Now p of x minus x square will be another polynomial. For that polynomial, see, as x is when you take x is equals to 1, p of 1 minus x square 1 is found to be 0. That means x minus 1 will be a factor of this, As usual, x minus 2 will also be a factor, x minus 3 will also be a factor, x minus 4 will also be a factor, x minus 5 will also be a factor. So can I write p of x minus x square is equals to x minus 1 into x minus 2 into x minus 3 into x minus 4 into x to the x minus 5. Very basic fundamental, friends, very basic fundamental. Just do understand this, do understand. And what is the purpose of giving this leading coefficient unity? That means here, like if you are going to multiply all this, you will be getting x to the power 5. So that's the reason here it's already 1. If it is something like leading coefficient 2, you could have taken 2 here. So our required polynomial should be, now our required polynomial is p of x now. Therefore, p of x will be equals to product of all these, that is x minus 1 into x minus 2 into x minus 3 into x minus 4 into x minus 5 plus x square. Yes. And this is our required polynomial. Now just put, to get p of 6, put x equals to 6. That becomes p of 6 is equals to 6 minus 1, 5, 4, 3, 2, 1 plus 36. 5 4s 20, 23 60, 62s 120 plus 36. Hence our answer is 156. Very simple thing, very simple thing. But see, if you just see that particular pattern, we may think that p of 6 is equals to 36, and immediately we'll be lucky. See, even 36 option was also given. So just make sure, like whenever they give you some things now for objective purpose, for competitive, mains and advanced, they'll try to twist the question, they'll try to twist us. Okay, good. Yeah, f of x be something polynomial. F of x is divided by x minus 1, x plus 1 and x plus 2. Then reminders are 5, 3, 2 respectively. When f of x is divided by x cube, just simple things, friends. Factorize this. Factorize this. Because by trial and error method, how do we factorize the cubic equation? By trial and error method, it is very simple that coming to this particular polynomial, now x cube plus 2x square minus x minus 2. It is observed to be x minus 1 is a factor of this, because if you take x is equals to 1 now, if you take x is equals to 1, what happens, boss? 1 plus 2 minus 1 minus 2. Yes, 1 plus 2, that becomes, so p of 1 is 0. Hence you take, so now you just divide this x minus 1. Okay, what do you get, friends? X minus 1 into this particular thing will be like x square, x into x square, you get x cube, minus 1 into x square is minus x square. Change the signs. 2x square plus x square will be 3x square minus x minus 2. X we have, 3x square we have, then what do you get? X into 3x. X into 3x leads to 3x square, minus 1 into plus 3x minus 3x. So minus plus. So minus x plus 3x will be like 2x minus 2. X minus 1, here we have 2x. So plus 1, yeah, plus 2. That becomes 2x, x into 2, 2x minus 1 into. So that becomes, when we change the signs, remainder is found to be 0. This can be factorized in like x plus 1 into x plus 2. That's it. As this, now this can be expressed easily as x minus 1 into x plus 1 into x plus 2. Now all the things that whatever we have discussed in remainder theorem, just use. So I'll just give you this as homework. Okay, good. Next thing, same almost now, like f of x is a fact, f of x is given, is a polynomial that it's a basic question, friends, basic question from grade 10 polynomials. Very simple now. Like you take x is equals to 1, you get an equation in a and b. You take x is equals to minus 1, because they are factors now. Like no, they are just reminders. They have given, see, f of 1 will be 5. F of minus 1 will be 19. From these two, you'll be getting a 2 linear equations in A and B. Now, if you're going to solve these 2 linear equations in A and B, you'll be getting the values of A and B. Of the moment you get the values of A and B, just substitute in that, you'll be getting polynomial. Now, put x equals to 2. We require f of 2. That's it. Clear? Good. Next. Yes. Now another interesting. Now we are done with basic things of number systems, whatever we require for competitive spirit. Polynomials we are done. Now we'll be entering into another like basic inequalities, basic rational inequalities. Very important, friends, very important, because this particular funda will be like almost in every topic, every grade 11, 12, we are going to use it. So please make sure you understand. Before we start it, first let's try to understand intervals. How many types of braces we have? We have only 3 exclusively. One is closed or square braces, we say, open braces or parenthesis, or next flower braces or curly braces, we say. First, we go with open interval. Friends, if you say x belongs to open a comma b, a should be less than b. X is any real number, a less than b. Then if x belongs to open a comma b, I mean to say x takes all the values from a to b except a and b. You understand? That means this is x such that a less than x less than b, that is endpoints are not included in this. Closed interval, if I say x belongs to closed a comma b or square brackets a comma b, then I say x such that a less than or equals to. So whenever I get this closed braces na, I get equality also. Please make sure. So here endpoints are included, and this is possible only when both a and b are finite. Yes, that is very important, because yes. Next, open, semi-open or semi-closed intervals, we say. Here for this open a, here closed b. So wherever we have closed braces, that will be included. A is excluded and b is included. Closed a comma open b, a is included and b is excluded. Next, if I say again like x belongs to flower brackets a comma b, if I say, then I mean to say x is only equals to a comma b. Okay, only a comma b are included, not the values in between a comma b, only a comma b. So like open braces we have seen, square braces we have seen, curly braces we have seen. Now, very important part, basic inequalities. As we have done, as we are clear with intervals now, we'll be discussing. Friends, there are some basic rules, like we'll be going with this like a beautiful method called, interesting method of solving inequalities called wavy curve method. I'll tell you, wavy curve, in the name itself it is very clear, na? I'll tell you why it is being named too. Okay, consider an inequation. Okay, consider like, okay, g of x was given, friends, like g of x is equals to something. This is generalized method. First thing, if I come across like, if I get something like any g of x, a function g of x greater than or equals to a real number a, or less than or equals to a real number a, less than a or greater than a. A function g of x greater than or equals to, less than or equals to, or greater than or less than a real number a. There are some basic fundamental that I require. Acha? Number one, the first most important thing, number one, please make sure simplify this expression and make it in terms of like either some capital G of x greater than or equals to 0, or less than or equals to 0, or greater than 0 or less than 0. That means the right hand side part must be 0. First step, make sure the right hand side part is 0. Okay. Number two, factorize both numerator and denominator. Factorize both numerator and denominator. Make sure that you are getting linear factors. Number three, Find critical points. Find critical points. What are critical points, boss? Equate each and every factor, each and every linear factor of both numerator and denominator to 0, then corresponding values of that variable x will be our critical points. Okay, find critical points of both numerator and denominator. Number 4, very important. Once you get critical points, friends, whatever the critical points of the denominator, make sure that you are excluding them on the number line. Critical points of the denominator must be excluded and critical points of the numerator must be included. I mean, CP of numerator are included in solution and critical points of denominator are excluded in solution. That means on number line. Very thing. See now, and one more important thing too. Whenever you are simplifying this expression, please make sure that the coefficient of variable in each linear factor, is always positive. I mean, see friends, like suppose you got this thing like x minus 1 into 2 minus x divided by some x plus 3 greater than 0. Here if you just observe one particular thing, the coefficient of x is -1. So multiply with a negative sign both sides. And before, I would like to tell you one thing, that is, whenever we have a basic inequality, friends, suppose if I say x is greater than a, if I am going to multiply with a negative integer, on both sides, number 1, multiplying negative integer both sides, the inequality sign changes. Number 2, multiplying both sides with positive sign, positive integer or positive number, then there is no change in the inequality sign. And third most point is very, very important thing, that is, and if you are not knowing the sign of a particular expression, sign of a particular number, that means suppose if you have something, if I take x plus 2 is an expression, I don't know whether it is positive or negative, because it always depends on the value of x. When you know that, like when you are not sure about the sign of an expression, never multiply it. Okay, good. Sign unknown, then don't multiply or divide. Okay, clear? So these are the things. So now coming to the 5th point, what I mean to say, here if you observe the coefficient of one factor x, in this particular linear factor the coefficient of x is negative. So in that case you multiply both sides with a negative sign, that means x minus 1 into x minus 2 divided by x plus 3. As you are multiplying with a negative sign, the inequality sign changes. Okay? Very good, friends. So these are the 5 most important points that you are supposed to understand whenever you are solving any inequalities. Let's do some basic things on it. Yeah, that is whatever the points that we have discussed. Points where numerator becomes 0 are called zeros, that means critical points, are roots of the function. Where denominator becomes 0 are poles of the function. That means the critical points of the denominator are said to be poles. First we find the zeros and poles of the function, that we finding critical points. We equate each numerator factor and denominator factor to 0. Then we get corresponding zeros and poles. Then we mark all the zeros and poles on the real number line, put a vertical bar and something determining the sign. Fine. Let's see this now. one beautiful example we have. Friends, we are going to solve this particular expression. This is already been factorized, so we are not going to put much effort on it. But in case, like if it is not being factorized, and the right hand side is not 0, first thing, make sure the right hand side is 0. Number 2, factorize that particular expression. Factorize into linear terms. Okay, good. Coming here, x minus 2 into x minus 4 into x minus 4. x minus 4 into x. Very beautiful expression. First thing, as we have only everything in numerator, just we'll be getting only zeros. So first find critical points. Okay, how do we get critical points, boss? Equate each factor to 0. That means if I equate x minus 2 to 0, I get x is equals to 2 as a linear factor. If I equate x minus 4 to 0, I get x equals to 4 as a critical point, x 6 as a critical point. So I get, what are the critical points that I got now? 2, 4, 6. Please do understand this particular beautiful expression, friends, and check whether the sign of the variable x is always positive or like positive in all the three factors or not. Okay, yes, it is positive. So now see, this is number line from minus infinity to plus infinity. All the real numbers will be lying on it. Now arrange these critical points on this number line. Now arrange these three critical points on the number line in ascending order. That means 2, 4, 6. Next, friends, very simple thing. The moment you arrange them, just top right extreme corner, from there you start the graph, start the curve. You come to 6. Okay, by default, irrespective of anything we take, top right extreme corner, from there to the first critical point from right. From now just stop here. Look at the exponent of this particular factor, x minus 6. The x minus 6 as odd power. See here, all are having odd powers. So if the factor has odd power, make sure that you are going to change the curvature. That means from now we are on the top of the number line, will be changed to from top to bottom. Okay, clear? Yeah, sounds good. Next, now we are at 4. Even like x minus 4 is also having odd power. Now even we are going to change the curvature of it. Next, we are at x minus 2. Even x minus 2 has odd power. In case, friends, just do understand, suppose if x minus 2 has something like 2, power 2, then what could have been done? As x minus 2 has even power, then we would have not gone to the bottom of the number line. We could have changed from here to here. Okay, clear? So now we'll go with the actual problem. So this is why we say wavy curve method, friends. Wavy curve method. By this, the solution can be found very simple, friends. Very simple. Now here we have greater than 0. See, do understand one thing. Greater than means all the region. See, coming to the number line, the region which lies above the number line, is always said to be positive region, and the region which lies below the number line is said to be negative region. Now you just understand, like the curve is above the number line from 2 to 4 as well as from 6 to infinity. So I mean to take x belongs to, now do we have only inequality or even like equality? No, only inequality. So we go with only open interval. So x belongs to 2 to 4. From 2 to 4, union means or, like that means we are not done with the complete solution. You can even take either from this or from this. Open 6 to infinity. So this is how we frame the beautiful solution of this inequality, friends. Very simple now. First, make sure the right hand side part is 0. Yeah, point number 1. Number 2, factorize everything. Number 3, make sure that the sign of coefficient, like sign of the coefficient of x is always positive in that. Number 4, factorize everything like as we have done. Then get the critical points, arrange the critical points on the number line in ascending order, then go with wavy curve, When you are going with wavy curve, please make sure you are checking the exponent of each factor that you have. So this could be the solution of this particular inequality. That means for all the x belongs to this particular region, this expression is always positive. Okay? Give me thumbs up. Good. Friends, another one, like x into, we have this expression, x into x plus 1 whole divided by x plus 2. Yes. Now see, now we have like numerator x into x plus 1, denominator x into just x plus 2. Find the critical points of both numerator and denominator as it's already being factorized. So what are the critical points that we have? this x means x minus 0. X means x minus 0. So 0, minus 1, minus 2 are the three critical points that you got. Nah? Good. Now just draw the number line. The number line is from minus infinity to plus infinity. Arrange all these critical points on the number line in ascending order. In ascending order. Next, from top right extreme corner, top right extreme, draw a curve to the first critical point. From here, now come to x minus 0. X minus 0 has odd power. So you are going to change the direction of this particular curve. Minus 1 again, x plus 1 again, same. So we need greater than 0 na. Therefore x belongs to, friends, from minus 2 to minus 1 union 0 to infinity. Hope it is clear. Yeah, is it making sense? I hope it is making sense. Very good. Next thing, yeah, we can use everything here now. Friends, here like everything is being factorized already. Right hand side is being 0. Now if you just do understand this one, what are the critical points that we have? 2, minus 1 and 4. So just take the number line from minus infinity to plus infinity and plot all these in ascending order. Minus 1, 2, 4. Now as usual, from top right extreme corner to the first critical point, we just will be drawing the curve. Okay. Now from 4 we'll be checking. X minus 4 has odd power, so we are going to change it. Now at 2, x minus 2, friends, here we came to this particular instant. X minus 2 has power 2. See, if x minus 2 has power 2, that means the direction of the curve is not going to be changed. So from 2, that means from 2 to minus 1, I'm going to go with the same below the number line itself. At minus 1 again, it has odd power 3. So just changing. Okay, clear? Is it making sense? Good. Now x belongs to, as it is less than 0, friends. Less than 0 means, what do you mean by the less than 0? All the region which lies below the number line, will be like minus 1 to 2 union 2 to 4 you can take. Or friends, you can even just write it as, a continuous interval from minus 1 to 4. You are just eliminating this 2 from this. Yeah, this also makes sense, na? Instead this, either this or this. Hope it is clear. Is the fundamental things, concepts clear? Very good, friends. Very good. Yeah, like coming to another interesting question, friends. In this particular thing, the right hand side is not found to be 0. Right hand side is not 0. So see how our approach is going to be. X by x plus 2. What do you do to make right hand side to be 0? Just get the 1 by x to the left hand side. So you are just transposing 1 by x to the left hand side. Then as usual sign, 1 by x less than or equals to 0. You can just factorize na x LCM, x into x square minus x plus 2 into 1, x plus 2 into 1, x plus 2 divided by x times x plus 2, less than or equals to 0. Now that becomes x square minus x minus 2 whole divided by x into x plus 2, less than or equals to 0. Can the numerator be factorized? Yes, of course. Make sure that it is factorized. X square minus x can be written as minus 2x plus x minus 2. I'm just writing this one. Okay, so this can be written as like x of x minus 2 plus 1 times x minus 2 plus 1 times x minus 2. So that becomes x plus 1 into x minus 2. So only this numerator is going to be right now. This numerator is going to be factorized as x plus 1 into x minus 2 whole divided by x times x plus 2 less than or equals to 0. Clear till here? Am I making sense? I hope everything is making sense till now. Na? See, we brought the right hand side part to the left hand side. x by x plus 2 minus 1 by x less than equals to 0. We took LCM and we factorized the numerator. Clear? Now, what are the critical points that we got? What are the critical points? For numerator minus 1 plus 2, denominator 0 minus 2. Draw a number line. Draw a number line. Arrange all these critical points on the number line in ascending order. So that means like starting with minus 2, then minus 1, then 0, then 2. Now, friends, as it is seen here, all the both numerator and denominator factors, linear factors, are having only odd powers. So I can just, starting from to the right, extreme right. Is it beautiful? Yeah. Like that's the reason why we say way weaker. Now, what do we need? We need less than or equals to 0. Less than or equals to 0 means the region which lies below the number line. So I mean to say x belongs to from closed minus 2 to minus 1 union closed 0 to 2. But friends, you remember this thing? The most important point, critical points of numerator are included and critical points of denominator are excluded in solution. Critical points of numerator will be included, but critical points of denominator has to be excluded from the number line. Has to be excluded from the number line. So that means, friends, what are the critical points of the number line that we have? Denominator we have. One is 0 and the other is minus 2. So these two are being included in it. Yeah, these two are being included. Included means, suppose if you are taking closed minus 2, then that means this is being included in it. So what can be done? That becomes final solution is x belongs to, this has to be excluded. So just go with open brackets minus 2 to minus 1 closed union open 0 to closed 2. Guys, I hope everything is clear. So this will be the perfect solution for this particular problem. Hope it is everything clear now. Like one more thing, like why did you go with closed brackets here? Because apart from inequality, we also have equality. So that's the reason why we have taken, only this part. Hope it is making sense. Very good, friends. Very good. Now, same again, right hand side is not being found to be 0. In that case, what do you do? X square plus 6x minus 7 whole divided by x square plus 1. You just take minus 2 to the left hand side. That becomes minus 2 less than or equals to 0. Okay. So x square plus 6x minus 7 times minus 2 times x square plus 1 whole divided by x square plus 1 less than or equals to 0. I'll tell you one most important thing in this. X square minus 2x square, that becomes minus x square. 6x minus 7 minus 2 minus 9 whole divided by x square plus 1 less than or equals to 0. One most important thing, as we have already discussed, friends. See, the denominator we have x square plus 1. X square plus 1 is a particular quadratic expression which is always positive for all x belongs to capital R, because x is square of something. For square of something we are adding 1. So this will be always positive. When you know that this is always positive, you can just transpose to the right hand side. Clear now? You can just take this to the right hand side. So that makes minus x square plus 6x minus 9 less than or equals to 0. That's it. No need to deal with this particular x square plus 1 because it is always positive. If it is always positive, it is not at all going to affect our particular inequality. Yeah? Good. Now, see, as the coefficient of x square here is negative, I am just multiplying with minus. So, x square minus 6x plus 9. When you are going to multiply negative sign, the inequality sign changes. As you already know, So that becomes greater than or equals to 0. Now friends, see, x square minus 3x plus 9 is nothing but x minus 3 whole square greater than or equals to 0. Friends, one basic funda here, one basic funda. X minus 3 whole square, square of a linear expression. Square of anything will be always greater than or equals to 0. So that means here for all the solution will be x belongs to capital R, means for any value from minus infinity to plus infinity you take x minus 3 whole square will be always greater than or equals to 0. Hope you understood. See, such an interesting one, so like from this you can come to one particular conclusion. In any basic inequality problem, friends, in any basic inequality problem, the approach is almost everything same. Approach is same. What we are doing, right hand side we are converting into, we are making it to 0. We are factorizing, finding critical points, plotting the critical points on the number line in ascending order. We are going with the drawing wavy curve, with checking exponents of each factor, then getting the solution from that. That's it. Hope this particular part is clear. Very good, friends. This is a direct question. I'm just giving you as homework. Yeah, very good. Please take the question. Direct question, homework. Direct. See, we are not going to simplify anything. Just putting all the factors, finding all the critical points, arranging critical points on the number line. What are being included, what are being excluded. Please make sure you are going to exclude the critical points of the denominator in the solution. Okay, good. Next, even this be same like homework I am giving you. All are being factorized. All are being factorized. X power 4 into x minus 1 whole cube into x plus 2 whole square. Make sure you are doing it, okay? Make sure you are doing it. One most important thing, friends, one most important basic fundamental I need. We know na ax square plus bx plus c is a quadratic expression. Imagine discriminant is less than 0. If the discriminant of a quadratic expression is found to be less than 0. What do you mean by discriminant less than 0? Then no real roots. No real roots. That means, suppose I consider this situation, a is greater than 0. Always remember, friends, the graph of y is equals to ax square plus bx plus c will be like parabola. It all depends on the sign of the coefficient of x square. If a positive, it will be upward parabola. If a negative, it will be downward parabola. So, when discriminant is less than 0 and a greater than 0, that means the graph ax square plus bx plus c is neither going to touch nor intersect the x-axis. Is that point clear? Because if it touches or intersects x-axis, we will be getting roots. But here discriminant is less than 0. When the discriminant is less than 0, it is neither going to touch nor intersect x-axis. So the graph will be like this, like clear? Neither going to touch when a is greater than 0. If a less than 0, the graph is going to be. Not only in this way, like it can be in any way. I mean, okay? So this is the case when a is less than 0. Now understand a basic fundamental thing which is being embedded here. These are the values of y. These are the values of y. When discriminant is less than 0 and a is greater than 0, observe the like corresponding ax square plus b. This graph is like only having positive values, na? Only positive. So when d is less than 0 and a greater than 0, ax square plus bx plus c is always positive. Is always positive. And coming to this instant, the graph is ax square plus bx plus c, downwards parabola, opening downwards. These are the corresponding values of y. If you just see, this is negative y-axis. That means any value of x you take, y is going to take only negative. Therefore, when discriminant of a quadratic expression ax square plus bx plus c is less than 0, that means the sign of the expression ax square plus bx plus c is always equal to the sign of the coefficient of x square. If coefficient of x square is positive, then the expression is also positive. If the coefficient of x square is negative, then ax square plus bx plus c, the quadratic expression, is also going to be negative. Now based on this, like how it is going to helpful in solving basic inequalities, that we'll try to understand by one particular basic example. See friends, very simple, very simple. Do understand this. Here we have x square plus x plus 1 into x minus 1 divided by x square plus 3x plus 2. We can just factorize now, x plus 1 into x plus 2. Clear? Greater than 0. One thing, one basic thing. If you just try to understand this particular thing here, this is a quadratic expression. This is a quadratic expression and the discriminant of this is less than 0. Just check this. B square minus 4ac. Discriminant of this particular quadratic expression is less than 0. When this discriminant is less than 0, just now we have seen it all, the sign of this expression depends on the coefficient of x square. Here what is the coefficient of x square? 1, which is positive. So this is going to be always positive. This is going to be always positive. If this is positive friends, does it affect our inequality? Not at all. That means x minus 1 by x plus 1 into x plus 2 will be greater than 0. You can just exclude it, remove it, not necessary at all. So that becomes friends. Now we know now this is simply a linear factor, numerator, denominator already been factorized. We know how to check this. Clear? So this is how we are going to use the sign of the quadratic expression in solving basic inequalities. See, imagine friends, like if you don't know that particular, see, we could have just factorized this. We could have got irrational factors. Very complicated. So just don't, always remember, for an expression, for a quadratic expression ax square plus bx plus c, if the discriminant is less than 0, that sign of that expression will always depend on the coefficient of x square. Clear? Guys, next, one more important thing in basic inequalities, that is like if something in f of x, like anything which is of the form 0 by 0 form, like for any value of x, if you are going to get 0 by 0, that has to be eliminated. That has to be eliminated from the solution. I mean, suppose if I say f of x is equals to x minus 1 into x plus 2 divided by x minus 1 whole square into some x plus 3. Okay. See, I can cancel this. I can cancel x minus 1 and x minus 1 whole square only in the case that x shouldn't be 1. So, if you are going to get x equals to 1 in the solution, please make sure you eliminate that part. That is what I mean to say. You can cancel this, no issues in that. But when can you cancel? When you are sure that it is not 0. So, x shouldn't be 1 in this case. In the same, if you are going to get 1 in the number line, 1 in the solution of this, then exclude that part. Clear? Clear? Good. Bas, okay. Next one. Let's see this. Everything same, like x square minus 5x plus 4. This can be factorized. X square minus 5x plus 4 can be factorized into x minus 1 into x minus 4 into x minus 1 whole divided by x minus 1 into x minus 2. Friends, again almost the same which we have taken now. I can cancel x minus 1 and x minus 1. Why? On only one thing, it costs only one thing, that on the condition that x shouldn't be 1. Beautiful. X shouldn't be 1. That is my basic funda which I am supposed to take in solution. So, x minus 1 into x minus 4. Imagine that this is less than or equals to 0. Okay? Less than or equals to 0. The whole divided by x minus 2 less than or equals to 0. Now, what are the critical points that I have? 1, 4, 2. Arrange these critical points on the number line in ascending order. 1, 2, 4, as these all the three are having only odd powers. So, right, now what is our solution? If it is less than or equals to, that means all the region which lies below the number line, that means minus infinity to 1 closed union, 2 to 4 closed. This could be our solution. But friends, remember one thing, x shouldn't be 1. If x is not, why x shouldn't be 1? Because if x is 1, I can't cancel this. X, like the function will be 0 by 0 form. So this should be this should be made open brackets. This should be made open brackets. Therefore, my final solution is x belongs to minus infinity to 1 open union closed to 4. Hope it making sense, friends, huh? So this is clear, like, so that's the reason why we have eliminated 1. But one more thing, here even denominator we have x minus 2 na? X minus 2 we have it in the denominator. So this 2 has to be, critical points of denominator must be excluded. So that means here also we are supposed to go with open brackets. So that becomes x belongs to open minus infinity to 1 union open to 2 closed 4, we say. Open to 2 closed 4. Hope it's fine, dear. Very good, very good. So friends, so this is clear regarding number systems, polynomials, basic inequalities, rational inequalities, whatever we have. Even in this we have seen some cases too. All the principles. So always make sure that you're enough thorough with all the principles, friends. And whatever the problems that are given, assigned to you as homework, please make sure you're going with them too. Okay? Yes. Next. Next, we are going with most basic fundamental function called modulus function, which is very important. Like complete session is of like, we'll be coming across everything, but most important in calculus, even in trigonometry, everywhere is modulus function. Let's try to understand what is modulus function. Okay, good. Friends, modulus function. Modulus function is also called as absolute value function. Modulus function is also called as absolute value function. Absolute value. So first let me try to understand what is this absolute value, what is this modulus. Suppose a function, we say f of x is any function such that f of x is equals to mod of, I mean modulus is denoted like mod of, this is like input of this. We call this particular vertical lines as mod of something. So whatever which is being entered in between these two lines, that we say input of that particular modulus. This is what we say modulus function. If I say f of x is equals to mod x. Mod x is an absolute value function. I mean the output of modulus is always positive irrespective of its input. First, let's try to understand its domain and range. Before that, let's go with some examples to get good clarity on this. Friends, output positive means though your input is negative, the output is going to be positive. Though your input is going to be, output will be always either positive or 0. I mean, see friends, now suppose if I take mod of 2, yeah, it's 2 again. Mod of minus 2, it's plus 2 only. But see, do understand why, how it became plus 2. Already we have a negative na. For that negative, we have multiplied a negative sign. So to make a negative positive, we are like, so in the function itself, multiplying negative by default, minus of minus 2, then we get positive. Yeah, mod of 0 will be always 0. So the output of modulus function, is either positive or 0. Either positive or 0. But input can be positive, negative, 0. That means I can define f of x is equals to mod x as mod x will be x for all x greater than or equals to 0, and mod x will be equals to minus x if x is less than 0. Friends, don't get confused here. X less than 0 means x is already negative. To make that as positive, we are multiplying with minus x. We are multiplying with negative. So that means mod x is defined as x for all x greater than or equals to 0 and minus x for all x less than 0. That means I say, like suppose if I have a function itself in modulus, f of x mod, this will be f of x if f of x is greater than or equals to 0, and this will be minus of f of x if f of x is less than 0. Very simple, friends. Do understand the basic thing. And coming to domain and range. Friends, as you have seen, domain is input. What are the values that I can take input? A can take positive, negative and 0. That means the domain of modulus function, is set of real numbers, whereas range is only, I said, positive or 0 na. So from close to 0 to infinity, this is range and domain of this modulus function, I say, friends. Hope it's clear. Very good. Now let's try to define these functions. In how do we define modulus functions? See, that is very, very, very simple. Just do understand. First we'll go with question A, example A. Define modulus of x cube minus x. Please make sure you're already thorough with all the rational inequalities that we have already seen till now. Now, how do we do this? Factorize mod of, this can be factorized as x of x. X can be taken common, yeah. But this can again be factorized of x into x minus 1 into x plus 1. Forget about modulus, friends. Forget about modulus. If this is like x into x minus 1 into x plus 1, what is the nature of this inequality? Like we have seen now, taking critical points 0, negative 1 and 1. Plotting all these critical points on the number line. That means minus 1, 0, 1. All are having odd powers. So that means, friends, this inequality, that means only this inequality is positive in this region and negative in this region. Yeah. By default, this is positive in, like, I mean to say, this x of x minus 1 into x plus 1 is positive for all x belongs to what? Minus 1 to 0. I'm just taking closed brackets. Again, like always, modulus, whenever you come to modulus, like equal to 0 can be taken either with negative or positive. So by default, in general, we'll go with positive sign. Okay. So x into x minus 1 into x plus 1 will be greater than or equals to 0 if x belongs to closed minus 1 to 0 union 1 to infinity. And this function and x into x minus 1 the same is negative if x belongs to minus infinity to 1 union 0 to 1 open. So you know, like where this is, like you already seen na, f of x, mod f of x will be f of x where f of x is positive, and it is minus of f of x where f of x is negative. So whenever the expression is negative, we just put minus there. That means, friends, by this we can just write this as very simple na. This is equals to the same x into x minus 1 into x plus 1. This function is equals to, that means modulus of x cube minus x is equals to x into x minus, I mean, like directly I am writing, why go with factors? This is equals to directly x cube minus x if x belongs to, where is positive? Closed minus 1 to 0 union closed 1 to infinity. And this is equals to minus of this, because in this region this is already negative. So negative of negative, positive. That means minus of x cube minus x for all x belongs to minus infinity to 1 union open 0 to 1. Hope you all understood, guys. Very simple na. First whatever the value, whatever the function that we have in modulus, first we'll be analyzing it. Yeah, x cube minus x, that can be factorized. See, by basic inequalities we have seen this. This is going to be positive in so and so case, and this is going to be negative in so and so case. Now by the definition of modulus function, whenever the inbuilt function is already positive, we just take only that f of x, and if for negative we take minus of f of x for all x belongs to. So this is how we define any modulus function. Is that clear, friends? Is it making sense? Yeah, very good. Next, this one too, like yeah, this one. See, this is very clear, right? This can be written as just x minus 3 whole square root na. Whenever, friends, very important, modulus square root of x minus 3 whole square is nothing but not just x minus 3, not minus x minus 3. We just write mod of x minus 3. Okay? Root x square minus 6x plus 9 is nothing but mod of x minus 3. Now, very simple, na? How do you write it? Modulus of x minus 3 is nothing but, friends, will be equals to plus x minus 3 if x minus 3 is greater than or equals to 0. That means x is greater than or equals to 3. Yeah? And minus of x minus 3 if x is less than 3. This is how this function is going to define. Now I'll give you this as homework. You might be getting, see something, just get the critical points, friends. 2 power x minus 2 is equals to 0. From there 2 power x is equals to 2. 2 means 2 power 1, we got x is equals to 1. On the number line, 1, that's it. So this is positive, this is negative. So this will be like 2 power x minus 2. I'll just take one more slide. Modulus of 2 to the power x minus 2, modulus of 2 to the power x minus 2 will be 2 power x minus 2 if x is greater than or equals to 1, but minus of 2 power x minus 2 if x is less than 1. Very simple, friends, very simple. So I like whatever the function that we have, make sure that you are getting critical points based on the critical points that we have seen in our basic inequalities. The same methodology we are going to adopt here. Yeah? Good, 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 good. Awesome response I'm getting, friends. Awesome. Same again. Like see x square minus 7x plus 10. How do we can factorize this now? You can factorize this as x minus 2 into x minus 5. As we have already seen, friends. As we have already seen, minus infinity, plus infinity, what are the critical points? 2, 5 here. So directly I'm writing. That means modulus of x square minus 7x plus 10 is equals to directly x square minus 7x plus 10 if for all x belongs to which region, friends? Which is positive region, na? That is minus infinity to closed to union closed phi to infinity. And in the same way, minus of this entire thing, x square minus 7x plus 10 for all x belongs to open to phi. Hope it is making sense. Very, very, very important. How do we define a modulus function? Defining modulus function is much easy if you understand it. So just please make sure you are understanding the approach, boss. You are understanding the approach. And this one, like this is like tip, very important model. I would like to say, very, very simple, very simple. Just see this. I'm just taking everything on like mod of x minus 1 plus mod of x minus 2. I have a function called mod x minus 1 plus mod x minus 2. Okay, unlike this is not being factorized because it's not a multiplying of two linear, it is just addition of two modulus functions. How do we define them? How do we define these things? See guys, I'll tell you a most interesting one. Like first draw the number line. You can see na, what are the critical points that are being found here? One is 1, one is 2. One is 1, the other is 2. Yes, friends, like I'll tell you a box method which is easy as like to consider two boxes. Okay, let me take this as A, this as B. So my first box is A, second box is B, in that way. Now analyze the sign of these two boxes in the corresponding region. Greater than 2, like for a number greater than 2, for input greater than 2, for x greater than 2, you see just take 3 minus 2, this is positive, this is positive, so both are positive. Okay? 1 to 2, any number which lie in between 1 to 2, like 1.5 you take, 1.5 minus 2, so B negative, 1.5 minus 1, A positive, and less than 1 both will be negative. You can take 0. Okay, understood this thing? Okay, that's it, very simple. Now I'm like my whole region from minus infinity to plus infinity has been split into 3 intervals. minus infinity to 1, 1 to 2 and 2 to infinity. First I'll go with case 1. If x belongs to closed to infinity, I am coming from right extreme, okay? In this region both are positive na, so I can just when x minus 1 is positive, mod x minus 1 is x minus 1 is itself, so that is the function will become x minus 1 plus x minus 2, directly 2x minus 3. Very clear, very simple. Bus. Case 2. When x belongs to this region, that means what is this region? Closed 1 to, already I have included 2 here now, so I just take open 2, okay? In this region, x minus 1 is positive but x minus 2 is negative. So as x minus 1 is positive, I take mod x minus 1 is directly x minus 1, but mod x minus 2 is x minus 2 is negative. So mod of x minus 2 is minus of x minus 2. Friends, is this making sense? Very important, because here in this particular from 1 to 2, x minus 2 is negative. According to the definition of modulus, if the input is negative, then we write it as minus of the input to make positive. So that becomes x minus 1 minus x plus 2. So minus 1 plus 2 becomes 1. So for all x belongs to 1 comma close to 1 comma 2, the function reduces to 1. Now case 3. Case 3, friends. This region, that is from x belongs to minus infinity to 1. Minus infinity to 1. No need to take closed because already you have taken closed here. Now in this region both are negative na. So I have to write x minus 1 as mod of x minus 1 as minus of x minus 1 and mod of x minus 2 as minus of x minus 2. Minus x plus 1 minus x plus 2, that becomes minus 2x plus 3. Hope you all have understood, guys. See, very simple. Such a basic thing na. Very, very, very simple. Box principle will keeps us always motivating. Okay, mod x minus 1 plus mod x minus 2. First, I understand the critical points. You know how to understand the critical points. What did I take? 1 I took, 2 I took. Arrange this number line. How many I have? Only 2. No, like imagine that if there is some more like plus x minus 3. Then I could have gone with one more box. So very simple. But intervals will be increased. Okay. Mod x minus 1 plus mod x minus 2. Let me take this as box A, box B. Sign of these two boxes in all the 3 intervals. Greater than 2, both are positive. Lying in between 1 to 2, A positive, B negative. Less than 1, all negative. So this is how we define. Now mod x minus 1 plus mod x minus 2. Finally, I can write this as, friends. So if I wish to write everything, how do I write this? That is equals to 2x minus 3 for all x belongs to closed to infinity. That's it. 1 for all x belongs to closed 1 to 2 and minus 2x plus 3 for all x belongs to minus infinity to open 1. That's it. That much easy it is. That much easy it is. Okay, friends, that's it. Very good, clear. Very good. So next, properties of modulus, which are very, very, very important. Yes, like for any two real numbers a comma b, mod a will be always greater than or equals to 0. Mod a, like inbuilt in mod a can be written as, that means I mean to say mod of 2x minus 3 we have. Even we can write this as mod of 3 minus 2x. So in modulus we can write anything. Okay, mod a is equals to mod of minus a. Again, this is important. Mod ab is equals to mod a into mod b. Mod a by b will be mod a into mod b on only one condition, that mod b shouldn't be 0. And as we already said, like very important, friends, modulus of a square is equals to mod a. Okay, square root of a square is equals to square. Apart from this, I would like to tell you one more thing. A square is also equals to like mod a whole square. Anything is fine. This is also equals to mod of a square. We can just write a square or mod a whole square or mod a square. This can also be included in properties as f. Okay, so these f properties in one of the, like whenever we discuss a particular function, friends, properties of it are very important. So if you are having enough strength in those properties, our approach will be very simple. Now let's do understand the graph of modulus function. Very important, friends. Graph of a modulus function. Graphing something. Suppose I have a basic modulus function y is equals to mod x. Mod x is function. To graph it, I generally take y is equals to mod x. Okay, first let me go with coordinate axis, boss. Tell you most simple technique, most simple one, most simple one. Mod x we have, na? Mod x. Mod of x. What is the critical point? Critical point means x is whatever we have, we equate it to 0. That means x is equals to 0 itself is critical point. That's it. Okay, x equals to 0 itself is critical point. Now to the extreme, to the right of 0, any value you take 1, so that is found to be positive. That means y is equals to, for right of 0, from 0 to infinity, y will be, mod x will be x. So y equals to x. Y equals to x. 1, 2. Because it's a straight line, we just need 1 point. Already we know 1 point. Already one critical point, you know. Now when x is 1, y is also found to be 1. So just, yeah, that's it. This is our y equals to x graph. You know it. Okay. Only in the region first quadrant. Because y equals to x is also carried to negative axis 2. Quadrant 3, 2. Now for less than 0, that means to the left of 0, y will be equals to minus x. So that means this is equals to x if x is greater than or equals to 0, minus x if x is less than 0. So if you take just x minus 1, then y will also be again plus 1. So the graph is going to be in this way. So this is what the graph of y is equals to mod x, friends. Graph of modulus function is very simple. Whatever we have in modulus, we just equate it to 0, we get the critical point. Okay, I'll go with one more small example. Just see, y will be equals to mod of x minus 3. Okay, simple, na? Simple. On the same graph, I would like to plot with some other color. First equate, like whatever we have it in modulus, we will be equating it to 0. Na? Good. So mod of x minus 3 to, like in modulus we have x minus 3, equate it to 0. You get x is equals to 3. Yes. So 3 is our critical point. Put a dot there. Okay. When x equals to 3, y will be 0. Okay. Next. To the right of 3, take 4 minus 3. So when x is 4, y is 1. So that means this is how the graph. When x is 2, y is again 1. Again, this is how the graph is going to be. So this is the graph of y is equals to mod of x minus 3. See, very simple. Whatever we have, it is in modulus. Graphing is very important, friends. Like graphing, you should understand how to get the graph of given equation, given expression. Very important. So graphing, only some basic principles. For modulus, whatever we have it in modulus, we equate it to 0, we get critical points. At that critical point, we get the corresponding y. Then just to the right 1 point, to the left 1 point. That's it. Okay? Okay? Good. So mod of 7 minus 2x. From basic properties, we already know now, we can write this as mod 2x minus 7. Yes? Very simple again. If you just take first what is the critical point? 7 by 2, na? Somewhere here we'll be having 7 by 2. Okay, to the right of 7 by 2, if I take 7 by 2 means something like 3.5. 4 if I take 2 4 the 8 minus. So if I take for 4, this is like y is going to be 1, and the same. So this is how we are going to get the graph of modulus of 2x minus 7. Friends, I request you to go with this as homework. Mod y is equals to mod 4x plus 5. Same approach is same. Equate the part which is in the modulus to 0. 4x plus 5 to 0. Then you will be getting the corresponding x value. That's it. Ho gaya. Khatam. Yeah. Good. Yeah, this is like one another interesting one. Like we have already seen in definition now, we have seen like how box cases, two box cases, no? First you have to define, to get the graph of any function, first we have to define it. After defining, then corresponding xy values, plotting it on the coordinate plane, we get it. Okay, now see, first defining this case, what are the critical points that we have? Simple. What are the critical points that we have? One is 1, one is other, 3 by 2, na? 1, then 3 by 2. 2x minus 3 is equals to 0, then x is equals to 3 by 2. So as you know friends, like box case again, we go with box case. Considering two boxes, okay? This is A, let this, like this be the first box, second box, first AB, AB. Friends, to the 3 by 2, both are positive, na? Positive, positive. 1, 2, 3 by 2. 1, 2, 3 by 2, if you take like less than 3 by 2, B is negative. Because if you take something like 1.2, 2 times 1.2 is 2 times 1.2, 2.4 minus. So this is negative, but this will be positive. Here both are negative. Okay, now that is case 1. Case 1 region, if you are going to take closed 3 by 2 comma infinity. In this region both are positive, no? So y will be equals to directly x minus 1. Already we have minus here, so just same, because this is positive, that will be plus only. So x minus 1 minus 2x plus 3. So x minus 2x will be, x minus 2x is something like minus x I have. Minus x plus 2. Y will be equals to minus x plus 2. Good. Next. Second region. What is the second region? From x belongs to closed 1 to 3 by 2. In this region, this is positive, but this is negative. Therefore, y I get like, this is case 2. That is positive itself, x minus 1. As this is negative, already we have a negative sign here. Negative of negative, that gets positive. So, plus 2x minus 3. Then that becomes, friends, 2x plus x. 3x. 3x minus 4 I get. Okay, good. Next, third case. To the extreme right, left of 1. That means x belongs to minus infinity to 1. Both are negative. That means minus of x minus 1. It's already like plus 2x minus 3. Y is equals to 2x minus x is x. Minus 3 plus 1 will be minus 3 plus 1 is minus 2. Good. Now see, do understand this, friends. Do understand this. Graphing, very, very, very important. Let me go with first coordinate plane. Okay. Plot the critical points. Whatever the critical points that you got on the number line. Here we have 1. Here we have 3 by 2. Okay. Now to the extreme right, in between 1 to 3 by 2, and to the extreme left of 1. So now first case, from extreme right of 3 by 2. What is the function? Minus x plus 2, na? Put first, for x is equals to 3 by 2, what happens? For x is equals to 3 by 2, what happens? Minus 3 by 2. Okay. X is equals to, when you take x is equals to 3 by 2, minus 3 by 2 plus 2. What it becomes? Minus 3 by 2 is minus 1.5 plus 2. That is plus 0.5. That will be, so here if it is 1, somewhere here we'll be having our 0.5. Yeah. We got 1. Are you able to follow? Next, one more point, like greater than 3 by 2, if you take 2, minus 2 plus 2 is 0. So when x is 2, y is 0. So just this is how the graph is going to be in this region. Clear? Next. In this region, you take 1 because 1 is a part of it. You take 1, 3 1s are 3, 3 1s are 3, minus 4. 3 minus 4, that is negative 1. If you are going to take like x is equals to 1 in this region, 3 1s are 3, 3 minus 4, minus 1. So y is negative 1. Yeah. So as usual, like now in the region from x belongs to minus infinity to 1, if you are going to take x0, corresponding you get y is equals to 0 minus 2, like you get y is equals to minus 2. So minus 2 will be somewhere, when x is 0, y will be equals to minus 2. So that means the graph is going to be in this way. That's it. So just define modulus, just define modulus. The moment you define modulus, this is how we are going to be. Okay, clear? Defining modulus is the most important thing that we do, friends. Next. Same. See why I say graphing the modulus thing is very important means, like there will be some questions which has to be done only by using graph. Only by using graph. See, look at this question. They are asking us to get the value of p for mod x minus 1 plus mod x plus 1 is equals to p for like 1 solution, 2 solution, infinite. Just do understand first, define this. Okay, what are the critical points that we have? 1 and minus 1. So just I'll go with box again. Minus 1 here, 1 here. 2 boxes I am considering as we have 2 parts. So just do understand, friends. Let me take this as some a, this as some b. So AB, always remember, like first as in the same order. So it's very simple that greater than 1 both are positive. Yeah. Yes. From minus 1 to 1, if you take 0, 0 minus 1. So the A is negative, B is positive. And here both are negative. Correct? Now, defining the function from first case, x belongs to closed 1 to infinity. When x belongs to closed 1 to infinity, both are positive. So I directly write p is equals to, instead of that, I do one thing. First, to get the value of p, first let me consider this as some y is equals to this one and y is equals to p. We know y equals to p is a horizontal line. First, let me try to simplify where y is equals to. Now, in case 1, this particular modulus function, y will be equals to case 1. What is case 1? X belongs to closed 1 to infinity. Here both are positive. So, I get 2x, directly 2x. That's it. Second case, if I take x minus 1 is negative, whereas x plus 1 is positive. So, that is second case is closed minus 1 to open 1. Now, in this case, y will be equals to minus of x minus 1. So, minus x plus 1. Whereas this is positive as usual it is. Plus x plus 1. Okay? Minus x plus x gets cancelled. Y will be equals to 2. Okay. Now, case 3 left. That is x belongs to minus infinity to minus 1. In this case, boss, if you are going like both are negative, so y will be equals to minus x plus 1 as well as minus x minus 1. So we get y is equals to minus 2x. Now we have defined the modulus. Once we define modulus, how we are going to go with graph approach? See, very important, friends, very important. Yes, plot the critical points on the number line. What are the critical points that we have? We have minus 1, we have plus 1. Okay, next, for greater than 1, we have y is equals to 2x. 2x means like first put x equals to 1. Okay, when x is 1, y equals to 2 na? Like this is 1, let this be 2. So when x is 1, y is 2. That's it. When x is 1, y is 2. When x is 2, y is 4. So somewhere like this it is going. Okay, this is the graph of y is equals to 2x. Now when x is minus 1, in this region, second region, when x is minus 1, second, irrespective of like any value from minus 1 to 1, you take the graph of this modulus is y is equals to plus 2. So this is how it's going to be. Like this is how it's going to be. Now less than minus 1 you take, less than minus 1, the graph is going to be minus 2x. Less than minus 1, if you take minus 2, y is equals to plus 4. So this is how the graph is going to be. Okay, understood? Now how we are going to relate our solution to this? See, this is equals to like mod of x minus 1 plus mod of x plus 1 is equals to p. We have to find the values of p for which p has one solution. For when this has one solution, we have to get the value of p. When this has two solutions, solution means like y equals to p is a horizontal line, friends. Y equals to p is a horizontal line. Imagine, friends, like if this is horizontal line, y equals to p can slide anyway. Now when it slides from 2 to about 2 I'm taking, it has exactly two solutions, right? So to get two solutions, the value of p can be like 2 to infinity. Any value from 2 you take, any value from 2. That means the value of p greater than 2, it has two solutions. One solution, like anywhere any horizontal line cuts this graph, we never get one solution. So here p, no solution, like no value of p. No p we get. Okay, infinite means, imagine, friends, if y is equals to 2, the horizontal line intersects the graph from minus 1 to find infinite number of times. So for infinite, y is equals to, like p is equals to 2, the value of p has to be equals to 2. Next, the last case, that is no solution. No solution means below 2, any horizontal line, like all these, like for p belongs to, for values of, that is from minus infinity to open 2 you take, it has no solution at all. See how beautiful it is. How beautiful it is. See, friends, mod x minus 1 plus mod x plus 1 is equals to p. For one solution, no value of p. For two solution, greater than p, greater than 2. For infinite, p equals to 2. For no solution, minus infinity 2 plus 2. Understood? Good. Next, we are going to solve mod equations. Very simple that we take. See, friends, whenever we have like mod f of x is equals to a, we directly take f of x is equals to plus or minus a. Very simple. Very simple. See, like, yeah, mod of x minus 1 minus 2, we'll go with this example. Beautiful. Mod of x, so if you are going to remove like outside modulus, mod x minus 1 minus 2 will be equals to plus or minus 5. Okay, now we split into two cases, that is mod of x minus 1 minus 2 will be equals to 5, one case, and mod of x minus 1 minus 2 is equals to minus 5. So in this case, mod x minus 1 will be equals to 7. In this case, mod of x minus 1 is equals to minus 3. If again mod x minus 1 is 7, means x minus 1 will be plus or minus 7. Again I split into two cases, x minus 1 is 7, x minus 1 minus 7. So x is equals to either 8, 7 plus 1, either 8, or x is equals to minus 6. Now mod of x, coming to this case, see friends, mod of x minus 1 is equals to negative 3. Is it possible? So modulus of any number cannot be negative. Hence the solutions of this equation are, one is 8 and minus 6. That's it. Hope you understood. Nah? Whenever you come across modulus equations can be solved very easily. Only one basic funda. That funda is mod x is equals to a. We take x is equals to plus or minus a. Okay. Next, another beautiful thing, like I have already discussed in properties. We know na, like a square can be written as mod a whole square. Yes, same we are going like, so x square can be written as like mod x whole square minus 7 times mod x minus 8 is equals to 0. This can be factorized now, friends. Can this be factorized? Can this be factorized? X square minus 7 times mod x minus 8 is equals to 0. So coming here in this particular question, mod x whole square, see friends, minus 8 times mod x plus mod x minus 8 is equals to 0. Like as usual, normal factorization. So mod x common, mod x of minus 8 plus 1 time mod x minus 8 will be equals to 0. So that means mod x minus 8 into mod x plus 1 is equals to 0. That means either mod x is equals to 8 or mod x is equals to minus 1. This is impossible. So here x will be equals to plus or minus 8. X will be equals to plus or minus 8. So the solution will be x is equals to plus 8 and minus 8. Hope you all have understood this case. Yes, friends? Good. Very good. Very good. Very good. Next, type 2, when we have like this, friends, again same, almost same. Like whenever we have, like suppose if we have mod x is equals to mod y, you again split into two cases, x is equals to y and x is equals to minus y. That is x is equals to plus or minus y. There is nothing in it. We'll just go with an example. See, friends, like either x square, like this should be equals to plus or minus. That means x square minus x plus 1 will be equals to plus or minus x square minus x minus 1. Now you take plus case first. X square minus x plus 1 is equals to plus times x square minus x minus 1. Or if you go with minus, minus x plus 1 is equals to minus of this, minus x square plus x plus 1. Now see, x gets cancelled. We got 1 is equals to minus 1. Is this possible? No way. That means you are going, this is not possible. You are going to exclude this. Now coming here, send everything to this side. 2x square minus 2x is equals to 0. X square minus x equals to 0. X of x minus 1, 0. That means x is either 0 or x is 1. So this is how we get the modulus in this case, friends. Mod x is equals to mod y, basic funda. X is equals to plus or minus y. That's it. Type 3, mod of f of x is equals to g. Same again, like, but one particular thing is very simple, that one, because like here g of x is a function. As usual, like you take f of x plus or minus g of x. But after getting the result, if a result, for some result, if g of x is negative, exclude that value. Because mod is equals to no negative, no? It should be only positive, no? So that's the reason. We'll go with one particular example. See, friends, like mod of x square minus x, that will be equals to x square minus x minus 6 is equals to plus or minus x plus 2. I take x plus 2 one case, and x square minus x minus 6 is equals to minus of x plus 2 in the other case. Okay, this case, if I take x square minus 2x minus 8 is equals to 0. Okay, this can be factorized as x square minus 4x plus 2x minus 8 equals to 0. X minus 4 into x plus 2. So x will be 2 comma 4, whereas in this case x square minus x minus 6 is equals to minus x minus 2. Minus x gets cancelled. X square is equals to 4. X will be equals to plus or minus 2. So overall what we get, minus 2, 2 and plus 4. But just do understand this. X plus 2, na, here. Minus 2. Minus 2 and 4 we get. That's it. Yes, minus 2 plus 2 and 4 we get. 3 values we got. But none of the values, see, if you just substitute here, for x is equals to minus 2, it's not negative. X is equals to plus 2, it's not negative. X equals to 4. Hence, all these 3 will be our values. That's it. X, okay. Okay, guys, understood? Now, coming to like a special case, or this can be like one among these, we have seen almost 3 cases now. Coming to 4th case, like whenever we have this f of x plus or minus g of x, the same we do go with, like we have seen mod of x minus 1. I'll tell you this one. This case comes under see, this is among one particular case, like getting the value of p corresponding to that. Okay, suppose in place of mod x minus 1 plus mod x plus 1, it is given 2 na. So what will be the value of x in that way? Same, first defining this modulus, then getting that particular conformed one. We'll go with that. Look at this, we'll go with this particular example. First we'll be defining it, okay? Define the modulus. Defining the modulus is important, friends. What are the two critical points that we got? One is 4 by 3 and the other is minus 3 by 4. 4 by 3 and minus 3 by 4. Minus 3 by 4 we have here and 4 by 3. That's it. Now consider boxes. Let this be A, let this be B. So AB, okay? AB, AB, AB. Greater than 4 by 3, both are positive. In between these two, minus 3 by, like if you take 0, this is negative and this is positive. So B negative, A positive. Here both are negative. Okay? Now, case 1, how do we, for x belongs to closed 4 by 3 to infinity. This is positive, both are positive na. So 4x plus 3x, 12 is equals to, like that mean, define properly. 4x plus 3x, 12x is equals to 4x plus 3x, I'm sorry. 4x plus 3x, 7x plus 3 minus 4, 7x minus 1 is equals to plus 12, 7x is equals to 12 plus 1, 13, x is equals to 3 minus 4, negative 1, correct. 7x is equals to 13, x is equals to 13 divided by 7, 13 divided by 7. Now one most important thing in solving modulus equations is, friends, now whatever the value that we got, x is equals to 13 by 7, check whether that value lie in this region or not. Okay, 4 by 3 is something like 1.11, yeah, for 1.33 something. But what about 13 by 7? 13 by 7 is a value which lie in between. 13 divided by 7, we get 7 ones, 7 ones. Then we get 5, 7 1 ja, 3 plus 3, 6, 7 8 is 56, 1.8. But value, this is something, 7 8 is 56 we get. This 1.8 lie in between 4 by 3 to infinity? Yes. Therefore, x is equals to 13 by 7 it takes. Okay, na? Next case, case number 2. Second case, if you are going to take, that means lying in between minus 3 by 4 to plus 4 by 3. In this case, friends, in this case, this is negative and this is going to be positive. So 4x plus 3 minus 3x plus 4 is equals to 12. That is, x belongs to closed minus 3 by 4 to open 4 by 3. 4x minus 3x is x and 3 plus 4 is 7, which is equals to 12. X is equals to 5. Yeah, but is x is equals to 5 lie in this region? No way. So we are going to exclude this particular part. And third one, both are negative. Minus 4x minus 3 minus 3x plus 4 is equals to 12. That is, minus 7x plus 1 is equals to 12 and minus 7x is equals to 11. X is equals to minus 11 divided by 7. Is minus 11 by 7 lie in between? Yes, this particular value includes. So always check that this region is like x belongs to minus infinity to minus 3 by 4. Always make sure that whether this is lie in this region or not. Whatever the result that you got, lie in this region or not, lie in this region or not. If it is not going to lie in that particular region, just exclude it. That's not our solution. Oh, sorry. Next. Yeah, we can go with the same way na. Homework, friends. Same, define these two modulus functions, then corresponding to that get the value of x. Okay, same as we have seen this particular one. The same way we are going to do in that way. Please make sure you do it. Okay, good. Now some special results in modulus function. Any equation in modulus should be one among those 4 models. But if it is not one among those 4 models, like this a very special case. It is very rare case. The case is like, you might be coming across some expressions, friends. First expression, something like mod A plus mod B. Whenever you see an expression, mod A plus mod B is equals to mod of A plus B. And mod A plus mod B equals to mod of A minus B. In these two expressions are very special case, because you can't take like critical points and then it's very hard to do. Okay, so in these two cases, very simple. If it is mod A plus mod B is equals to mod A plus B, make sure that the solution is AB greater than or equals to 0, and in this case AB is less than or equals to 0. Okay, I'll give you one particular thing. See, x square minus 3x plus 4. Okay, x square minus 3x plus 2 I take, mod of x square minus 3x plus 2 plus mod of 4x minus 3. Okay, able to follow? Now is equals to something like mod of x square plus x minus 1. X square plus x minus 1. X square plus x minus 1. In such cases, whenever you find such cases like mod A plus mod B is equals to mod A plus B, in such cases, my dear friends, I suggest you to do this. Mod A plus mod B, if it is of the form mod A plus B, then AB, the solution should be A into B. That means very simple na. See, this into this, that is x square minus 3x plus 2 into 4x minus 3 will be greater than or equals to 0. That's it. Ho gaya. Clear? You can factorize this, you can factorize by using our basic inequalities. So please kindly make a note of this. Very important, friends. Next. Yes, the next part is modulus inequality. Inequality, very simple, friends. See, just you have to understand, as we have seen the equality questions, inequality also of the same type. Like whenever you have like f of x, modulus of f of x less than or equals to, that means like minus a less than or equals to f of x less than or equals to a. So this is the basic rule we say. Okay, but in coming to problem, I'll tell you the approach, which is very simple. See, friends, and this is type 2. If it is greater than or equals to a, then f of x will be like minus infinity to minus a union closed a to infinity. Coming to problem part. Now coming to this particular thing, as usual, like see, basic thing, very simple, that is like the solution is like minus 1 less than or equals to same whatever the function that we have less than or equals to. But instead going with that, I'll tell you one particular very important, very useful, friends. Whenever I have like mod f greater than or equals to some g or less than or equals to some g, the basic thing, like I'll just add these two and subtract the inequality sign, whatever the inequality, same everything will be 0, 0, 0. Use this expression, that gives us very simple, friends. Okay, very. See now how the things are going to be. Now see, what I'm trying to do, x square minus 4x plus 4 plus 1 into x square minus 4x plus 4 minus 1 greater than or equals to 0. You understood? Very simple. So that becomes x square minus 4x plus 5 into x square minus 4x plus 3 greater than or equals to 0. Now friends, one thing which is very important. See, you have to just explain me this. What is the discriminant of this? D is equals to b square 16 minus 4ac, 4 5s are 20, less than 0. So this is always positive. This is always positive. So this is not at all going to affect us. Okay, so just go with this now. That means x square minus 4x plus 3 can be factorized to x minus 1 into x minus 3 greater than or equals to 0. That becomes here 1, here 3 by wavy curve. X belongs to what happens, friends? Minus infinity to 1, closed 1, union closed 3 to infinity. That much simple it is. Solving the inequations in modulus, very, very, very simple. What I said, if mod f of x greater than or equals to or less than or equals to some other, like just add them, subtract them, get same inequality, greater than or equals to 0. Okay, we'll go with next one. See, here again, like one thing is simple. See, just be practical, friends, be very practical. Mod of 3x minus 9 is positive, na? Plus 2 is again positive. But we have like mod of this. Why? Not necessary, na? Do you understand? So, positive is always like positive. So, mod 3x minus 9, directly I am writing plus 2 is greater than 2. Okay, ho gaya. Because this is positive, plus positive. So, no need of modulus again. Now, 3x minus 9, 2 goes to that side greater than 0. You can take 3 common. 3 of mod x minus 3 is greater than 0. Now, that is x minus 3 greater than 0. Friends, simple, simple, simple. Mod of something will be always positive. And 0, 2 or 0, 2. Okay, just exclude that. Exclude. See, for x is equals to 3, it is going to be 0. So that means solution is x belongs to R. From R, you are going to exclude this 3. Hope this makes sense. Clear? Very simple, friends. Very simple. The basic fundamental thing is very, very simple. Now, same again, like we have seen this, na? Modulus of x minus 1, that is minus 1 less than or equals to mod of something, like mod x less than or equals to a means a minus a less than or equals to whatever we have in modulus. Mod x minus 1 less than or equals to plus 1. Now add 1, 0 less than or equals to mod of x minus 1 less than or equals to 1 plus 1, 2. See, this is always true, na? This is always true because mod x minus 1 will be always greater than or equals to 0. So, no need of to get. But coming to this, now again, so modulus of x minus 1 is less than or equals to 2. That means minus 2 less than, or even right. Just now we have seen na, mod x less than or equals to a. What do we take? We just take x minus 1 plus 2 into x minus 1 minus 2 less than or equals to 0. That becomes x plus 1 into x minus 3 less than or equals to 0 by wavy curve minus 1 and plus 3. So less than, that means minus 1, 2 plus 3. Hope it makes sense. Very simple, basic, fundamental that we came through basic inequalities and all, friends. Okay. Same again, like this is of the form mod f greater than mod g. What I say? If mod f is greater than mod g, friends, I say again, f plus g into f minus g you take, and whatever the symbol that you have, put the same symbol greater than 0. I'll just do this and I'll ask you to go with the next one. Like f plus g, x plus 3 plus 2x minus 1. 3x plus 2 into x minus g, f minus g. X minus 2x is minus x and 3x plus 4 you get. That is greater than 0. But friends, here x coefficient is negative, na? X coefficient is negative. If x coefficient is negative, what happens? Multiply with a negative sign. So that becomes 3x plus 2 into x minus 4 will be less than 0. Now by using our wavy curve, we can solve this. Okay. The remaining part, please make sure you are doing it as homework, friends. So I'm just giving you this as complete homework. Even this homework, again, this can also be done as homework, but I'll just give you the outline of it. See, friends, mod of, like this can be written as mod of, like x plus 3 whole divided by x greater than or equals to 2. Is that clear? Do you understand? Mod x plus 3 whole divided by mod x greater than or equals to 2 by using modulus properties. Mod a by mod b is mod of a by b is mod a by mod b. Now mod x is always positive. Already in the basic things we have discussed. When you know the sign of the expression, when you know the sign of a particular expression, this can be multiplied both sides. So that becomes, friends, mod of x plus 3 will be greater than or equals to 2 times mod x or mod 2x. Both are same because 2 is anyhow positive. Okay. Now again this comes to the previous expression, that is mod f greater than or equals to mod g. What I said? F plus g into f minus g greater than or equals to 0. Same inequality. So friends, I am just giving you this also as homework. Clear? Awesome, friends. Awesome. Same kind of, again, friends, same. See, mod of 3x whole divided by mod x minus 4 less than or equals to 1. Mod 3x less than or equals to mod of x minus 4. Again, same. Mod f less than or equals to mod g. Ho gaya, boss. So, I am just giving you this also as homework, friends. My dear friends, whatever the problem that I allot you as homework, please make sure you do it. If you are getting it, that's it. Ho gaya. Now type 4, if it does not belong to type 1, 2, 3, in that cases define each mod, like we have now mod x minus 1 plus mod x plus 1 is equals to p case, that graphical one. Awesome problem. In such cases, they'll be asking you. In any case, if they are like we have seen 3 cases. In these 3 cases, if there is like something, if a problem is which does not belong to any of these 3 cases, then that belongs to type 4. In type 4, it is very simple. Define the modulus. First thing, define it and just simplify it. Okay? See, look at this one. Defining the modulus and getting it. This belongs to type 4. Friends, defining as usual, very simple. Like, what are the critical points that I have? One is minus 4, the other is plus 3. Considering 2 boxes as usual, friends. Let me tell you the most important thing in this. Very important problem. I want everyone to please pay attention here. Friends, greater than 3, both are plus. Here, like if I take this as A, this as B, AB, AB, AB. From minus 4 to 3, if I take 0, this is positive, B positive, yeah, but A is negative. Here both are negative. Now in this case, what happens, boss? First case x belongs to closed 3 to infinity. Both are positive, x plus x, 2x. Plus 1 is greater than or equals to 12. So 2x greater than or equals to 12 means 2x greater than or equals to 11. 2x plus 1. Now x is greater than or equals to 11 by 2. Most important thing. X belongs to closed 11 by 2 to infinity. Friends, here comes the most important part, and that part is whatever the solution that you got, you make sure that you are going to take the intersection of these two. Intersection. Now what is the solution from here? In case 1, the solution is in combining these two. See, 11 by 2 means greater than 5.5. It is from 3. So in common, what is the common to this? That is 11 by 2 to infinity. Okay, this is the first solution. Now first case solution. Second case lying in between these two, that is x belongs to closed minus 4 to 3. In this case, what happens? This is negative and this is positive. So minus x plus 3 and plus x plus 4 greater than or equals to 12. X gets cancelled, 3 plus 4, 7 greater than or equals to 12. Okay, does it happen? No chance at all. So this is eliminated completely. Now coming to third case. Third case is x belongs to from minus infinity to minus 4 open. Now in this case both are negative na. So minus x plus 3 minus x minus 4 is greater than or equals to 12. Minus 2x minus 1 greater than or equals to 12. multiply with the negative sign, 2x plus 1 less than or equals to minus 12, 2x less than or equals to minus 13, x is less than or equals to minus 13 divided by 2. Friends, minus 13 divided by 2. Now we have to take the intersection of these two. Intersection. Always remember in any corresponding case. Now what is the intersection of these two? X belongs to minus infinity to minus 13 by 2. Now we are not done. We are not done. We are not done. Now the important thing is, friends, the important thing is, whatever the cases that we have, all the cases, 3 cases we have now, you have to take the solution. The final solution is going to be the union of all these 3 cases. Union of all these 3 cases. Here we got. Therefore, final solution is x belongs to minus infinity to minus 13 by 2 closed. Union closed 11 by 2 to infinity. This is how we are going to solve a particular problem which belong to type 4. Very, 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 very important, friends. Very important. Very, very, very important. Okay? Good. Good, good, good. Next case. See, like this is something. Okay? We'll do it. Another problem. Here, like type 4 it is, like we have to define modulus here. Okay, so like see, x minus 1, we know na, like x minus 1 means critical point 1. So to the right one it is positive, to the left one it is negative. So we'll take first case. Case 1 is x belongs to closed 1 to infinity. Na, closed 1 to infinity. In this case, x minus 1 numerator is positive na, so x minus 1 divided by x plus 2 minus 1 less than 0. We are getting this. Trying to get formalize the things. X minus 1 minus x minus 2 whole divided by x plus 2 less than 0. X minus x gets cancelled. Minus 3 divided by x plus 2 less than 0. Multiply with a negative, boss. Multiply with a negative. That becomes 3 by x plus 2 is greater than 0. Only critical point which we have is minus 2. So that means x plus 2 should be positive. X plus 2 is greater than 0. That means x is greater than minus 2. Therefore, x belongs to what happens, boss? What happens? What happens? What happens? Open minus 2 to infinity. Now, as usual, as I said in the previous case, whatever the cases that we are getting, whatever the solution that we are getting through cases, in terms of cases, friend, whatever the solution that we are getting, make sure we are taking the intersection of these two. Now, coming to intersection, what happens? Intersection of these two, what happens? Therefore, x belongs to closed 1 to infinity only. This is not the complete solution. Solution in only case 1. Now, case 2. What is case 2? To the left of, that is x belongs to minus infinity to open 1. In this case, the numerator part is negative. So, minus x plus 1 divided by x plus 2 minus 1 less than 0. Minus x plus 1 minus x minus 2 whole divided by x plus 2 less than 0. Sorry, no. X minus x, that becomes minus 2x minus 1 whole divided by x plus 2 less than 0. Multiply with a negative sign, friends. Then you get 2x plus 1 whole divided by x plus 2 will be greater than 0. Now, what are the critical points that we have? One is minus 2 and minus 1 by 2. So, it is greater than 0 means x belongs to minus infinity to minus 2 union minus 1 by 2 to infinity. But as I said, we have to take the intersection na, minus infinity to 1 to this means what will be the intersection? Only intersection if you take only this region we get, that is x belongs to minus infinity to minus 2. Now, we are not done. Union, we have something to, yes, union minus 1 to 1 also we get, minus 1 to 1. We have to take the common region of these two, friends, common intersection. Now, once you are getting all the cases, please make sure that you find the union of all the cases that you got. Union, see, therefore this one and this one. Then you get x belongs to from minus infinity to minus 2 union minus 1 by 2 to minus 1 by 2 to open 1 we got here. Okay, here already closed 1 na? Okay, so directly you can take minus 1 by 2 to infinity directly. Hope you all have got my point, friends. So the thing is very simple. If a problem belongs to type 4 means none of the methods of type 3. In that case, define modulus in each case. Define modulus and get it. Define modulus and do the solution. Very simple. Defining modulus already we have seen. Nah? Friends, I want everyone to do this. Because like only defining modulus plays important role. That means see, only like what is the critical point we have? X is equals to minus 3. So here minus 3 we had. This is positive, this is negative. Nah? This is positive, this is negative. That means case 1 you take x belongs to closed minus 3 to infinity. Then you define x belongs to minus infinity to minus 3 you take. Then you get like whatever the solution here you get, you take the intersection. Whatever the solution you get here, you take the intersection. Now after all these, the union of all the cases, will be our required solution. Hope you understood. Please take this as homework, friends. Please take this as homework. You do it. If you're facing any issue, put it in the comment section. So with that we are done with modulus, friends. Next we'll be going to logarithm. So guys, the last topic of today's session is logarithm. Logarithm, we know, friends. There are two types of logarithms: basic logarithms, natural logarithms. Natural logarithms and basic logarithms. Natural logarithms we generally say ln, nothing but log to the base e we say. Basic logarithms will be having always base 10. Okay, basic logarithms or common logarithms we say. So every positive real number n can be expressed in exponential form. We know it, na? We know it. Where a is also a positive real number, different than other than unity, yes. And is called the base, x is called the exponent. Clear? Now we can write this expression a to the power x is equals to n in an equivalent form called logarithmic form, and that is what we say. See friends, a to the power x is equals to n can equally represented as log n to the base a is equals to x. Log n to the base a is equals to x. So this is what the equivalent form of this. Please make sure you understand this. Log n to the base a equals to x, nothing but a to the power x is equals to n. Hence, logarithm of a number to some base is the exponent by which the base must be raised in order to get that particular number. Next, let's try to understand domain of log expression, domain of logarithm, which is very important in log case. Whereas friends, whenever we define any function, it is very important that you define its domain and range. Okay. Suppose I consider y is equals to log x to the base a. I consider y is equals to log x to the base a. When I consider this, like domain means input, whether this value or even like both x comma a should be positive and the base shouldn't be 1. This is what the domain of logarithm expression. Understood? Domain of logarithm expression is x comma a belongs to 0 to infinity, and this base, whatever the base you have, that base shouldn't be 1. That's it. And coming to range is nothing but it takes all the values from minus infinity to plus infinity. Now let's try to understand the properties of logarithm, friends. Very important. Log 1 to any base a is 0, but make sure the base shouldn't be 1. Next, log a to the same base. Log a to the same base a is 1 and a base shouldn't be 1. Log n to the base 1 by n. This can be written as, like you can be written as log n. This 1 by n can be written as n to the power minus 1. So by using this exponential rule, this minus 1 can be written as 1 by minus 1 log of n to the base n. Whereas log n to the base n is 1, 1 by minus 1 is minus 1. That's it. Friends, TK, clear? Hope it is clear. Good. Now log mn to the base a, log m to the base a plus log n to the base a. Product, you will be getting sum. Division, you will be getting difference. This is another important, like log b to the power p to the base a to the power q is equals to p by q times log a to the base b. Next, this is base changing theorem, which is very important. We frequently come across. Means we can take an intermediate base and we can just replace it. See friends, very important. Log m to some base b can even written as some any base, like this base shouldn't be 1, some base m by log b to the base a. This can also be written as 1 by log. Whenever we write in reciprocal, the base and that gets interchanged. Clear? Next, another interesting thing, another important thing, the base, these two can be swapped with some base. A to the power log c to the base b is equals to c to the power log a to the base b. Like I mean to say, whenever you have something a to the power log some base, any base to log c to the base b, these two can be swapped. These two can be swapped. That means like c can be brought here, c to the power log a to the base b we can write it as. And one more thing, even whenever like you find this expression a to the power like same base log a something base, like this is always equals to b. Why? How means like you know na, these two can be swapped. So if you are going to get this side, then that becomes b to the power log a to the base a. Okay, so that becomes b. That we'll also be discussing in the property. No, yeah, you can just add this here, like hi property as some a to the power log b to the base a is always equals to b. Clear? Good. Yes, we'll go with problems, friends. Like log 2 to the base 7 is m, then find the value. See how important base changing theorem plays. Base changing theorem plays very important major role, and I want everyone to focus this. So yes, they have given log 2 to the base 7 value is m, then they are asking us to find the value of log 28 to the base 49. See, by using base changing theorem, why did we use, sir? Because in the given expression base is 7. So for that, this can be written as log 28 to the base 7 by log 49 to the base 7. That becomes, friends, log 28 is nothing but 7 4s are 7 into 4 to the base 7 plus log 7 square to the base 7. That becomes log 7 to the base 7 plus log 4 can be written as 2 square na. So 2 into log 2 to the base 7 whole divided by 2 times log 7 to the base 7. Friends, log 7 to the base 7 is 1 plus this is 2m, 1 plus 2m by 2. So hence this will be equals to half of 1 plus 2m. Hope you all understood, guys. Very simple, na? Very simple. Base changing theorem. That's it. Next. Here again, everywhere we almost use base changing theorem. Such an important expression it is. Such an important. See, let's try to understand. First, this is what given, na? What was given, like log a to the base ab. Always make sure that like complex shouldn't be in the base. Okay. For that, what I am doing, you know, like I can write this as 1 by 4 is equals to log ab to the base a. Na? Yes. This can be written as log a to the base a plus log b to the base a. Log a to the base a is 1. Na? So 1 by 4 is equals to 1 plus log b to the base a. From there, friends, log b to the base a value is 1 by 4 minus 1 is minus 3 by 4. Okay, let's try to use this. Okay, now we have everything like log b to the base a na. Let's try to convert this also in terms of base a. For that, how can we simplify, friends? Log Cubed root a, that can be written as a to the power 1 by 3 by root b, that means into b to the power minus 1 by 2 to the base ab. Hope you able to follow. Very good, very good. Now I am using base changing theorem to represent in terms of base a. So log to the base a to the power 1 by 3 into b to the power minus 1 by 2 whole divided by log ab to the base a. Log ab to the base a. Nah? Very good, very good, very good, very good. Yes. Already we know log ab to the base a value is 1 by 4. Okay. So 1 by 4, that becomes 4 of. This becomes, friends, like 1 by 3 times log a to the base a minus 1 by 2 times log b to the base a whole that's it. That becomes 4 times 1 by 3 log 1 by 3 minus 1 by 2 times this value is minus 3 by 4. That becomes plus 3 by 4. Okay. So friends, 4 times that becomes 1 by 3 plus 3 by 8. If you are going to simplify, 8 plus 9 divided by 3 into 8. 4 1 ja, 4 2 ja, 8 plus 9, 17 divided by 6. See how simple it is by using base changing theorem. Very simple, friends. So base changing theorem is very, very, very important. Okay. Very, 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 very important. See, this is again chota wala simple one problem. Simple one, just normal thing. See, 512 can be written as 2 to the power 9 na. So this 9 can be brought here. Now log 2 to the base 2. This is 1 eliminated. Now log 9 to the base 3. 9 means 3 square na. 2 can brought here. So this becomes log 3 to the base 3. This can also be eliminated. Now this becomes log 2 to the base 2. This is 1. So finally what happens? Only 1 to the base 5. Log 1 value is 0. So this whole value will be 0. You do it. You do it. You do it. I'll help you. Okay. Very good. Next. Another, like by using by using the basic properties of logarithm, log a plus log b plus and so on, that can be done in product na. So log of tan 1 degree into tan 2 degree into tan 3 degree into and so on tan 89 degree. Before that tan 88 degree. Okay. See friends, basic fundamental in trigonometry. Basic fundamental in trigonometry that we have is tan 89 can be written as tan of 90 minus 1, that is cot 1. This is cot 2, cot 3. Everything. Now tan 1 into tan 2 into tan 3 and so on. Like you get cot 3 into cot 2 into cot 1 degree. So cot 1 tan 1, as they are reciprocals, you get everything, like everything gets cancelled. Log 1 to some base is equals to 0. See, such a simple one, such a simple one. Yes friends, I hope everyone are able to follow. My dear friends, I would like to assign you this as homework. Please make sure you are doing this as homework. Just by reciprocal, you can just write this as log root BC to the base ABC. In that way you proceed. Okay. I want everyone to put your efforts on it. Just do it. Very simple. The same again, I would like to give you this also homework, because like see, 1 can be written as log Q to the base Q. All are having same base. Then everything you can write this as product na. Log of PQR to the base Q, you get this one. In the same, if you are going to reciprocal, then you get log Q to the base PQR. Friends, no. You have to do this, okay? Please do this homework. Next. We'll go with this, like using base changing or some, nothing, no, not even use of base changing, but very simple one. See friends, like very simple. Cube root of, like we have 5, like 5 to the 1 by no, that I can write it as log 7 to the base 5 plus 1 by 0.1 can be written as 10 to the power minus 1. 10 to the power minus 1. That minus 1 comes here. So log 10 to the base 10. That becomes 1. I repeat. Log 0.1. 0.1 means 10 power minus 1, boss. So minus 1 into log 10 to the base 10. Minus 1 into 1. So this is already minus. Minus into minus. That becomes I get plus 1. Now when I have same bases, friends, cube the root of, that becomes 7 here. 7 plus 1. Cube the root 8. I get 2. See, that's such a simple one. Such a simple one, my dear friends. Such very simple one. Now, by using base changing theorem, we can do this. I want everyone to put your efforts and complete this homework. Very simple. I'll just guide you. 20 can be written as 5 into 4, and that 4 again can be written as 2 into 2. So just simplify it. Okay, use the properties, put it in a simple way and just work on it. Even again, this can also be like we have everywhere like base 3 na. This can also be written as like log 2 to the base 3 by log 6 to the base 3 whole square. Now you do it, friends. You will get it everything. Will you? Awesome friends. Awesome. Almost this is also like same, but we'll do it. Okay. Okay. Now see, this 9 can be written as 3 to the power 1 by 2. Nah? 9 can be written as 3 power 1 by 2. So that becomes 4 power 1 by 2 plus 9 square is equals to 10 to the power log 83 base 6. 4 power 1 by 2 is 2. 9 square is 81. We can swap these. Nah? 83 to the power log 10 to the base 6. So 83 power 1 is equals to 83 power log 10 to the base 6. When bases are same, powers can be equated. That means log 10 to some base is 1. That means base should also be 10. See friends, such an interesting and easy one. Nah? Such very beautiful. Only by using properties we can do it, friends. Only by using. Even I am going to give you this also as homework, friends. Please do it. If at all, if you are facing any issue, put it in the comment section. I'll help you there. Even this, I'm giving you like this also has homework, friends. This also has homework. Very simple again. Very simple. Just do it. Try doing it. Put all your efforts. You will be getting it. No doubt at all. Next. Same again. This one, just solving the system of equations. There is nothing in it. Like if you are going to like simplify them, like if you are going to add all these three equations, what happens in everywhere, like log xyz to the base a is same, na, common. Then log x to the base a plus log y to the base a. If you are going to add all three, adding all the three, adding log x to the base a plus log y to the base a plus log z to the base a is equals to 48 plus 12, 60 plus 84, 144. Yes. Now see, log x base a, log y base a, adding nothing but again log xyz to the base a into xyz. That becomes whole square is equals to 144. So this value will be either plus 12 or minus 12. Then first take two cases, no issues in that. Take plus 12, then correspondingly you get substitute in that, you will be getting it. Okay. I want to complete this too. Homework, friends. Homework. Next one. Yes, logarithm equations. Equations are very simple. Solving logarithm equations is very simple. Only the basic funda you have to understand. What is that basic funda? Friends, whenever both sides you have log with same base, just equate it. That's it. Okay. But always check the validity of the equation. What do you mean by validity? Means you are supposed to check the domain. The input logarithm must be like always should satisfy that. Should be positive and base shouldn't be 1. We'll see this. Okay. Log of 4x minus 3 to the base x is equals to 2. Simple. Kya? Simple. Convert into exponential form. 4x minus 3 is equals to x to the power 2. Take everything to that side. X square minus 4x plus 3 is equals to 0. That becomes x minus 1 into x minus 3, 0. There you get x is equals to 1 and x is equals to 3. But friends, you just understand one thing. X equals to 1. Here x is base. So base shouldn't be 1. You are supposed to exclude this. and 3, 4 3s are 12. Yes, this can be taken into. So this is the only solution. You understood now? Check the domain. Check the domain. Check the domain. Check the domain. Even here same, like I'm giving you this as homework. See, I'll just tell you the rough procedure. 3 times this becomes log x to the base 7 plus you can write this as log x to 1 by log x to the base 7 is equals to 10. So that becomes, if you are going to take this as some k, so 3 of k plus 1 by k is equals to 10. Now you will be getting a quadratic equation in k. You can just factorize it and you get all. After getting k, please make sure whether that is the domain is getting satisfied or not. Domain is important. So this is homework. Next, 4 to the power something. Yeah, this can easily simplify na. See, like these two can be swapped. If that is going to swapped, what happens was x to the power log 4 to the base 2 minus 2x minus 3 0. But log 4 to the base 2 is 2. So x square minus 2x minus 3 is equals to 0. See, I'll tell you most important. X square minus 3x plus x minus 3 0. X minus 3 into x plus 1. That means x will be either 3 or x will be minus 1. Friends, do understand one thing. Do understand the most important thing here. We have x here. So log x, this will be defined for only positive. So this shouldn't be taken. That is what I am trying to say. Always after getting the solution, check the validity of the logarithm. Always check the validity, means check the domain. Now coming to the next problem. Log x to the power log root x to the base. That becomes, friends, see, x to the power log root x can be written as x to the power 1 by 2 na. 2x is equals to 4. This 1 by 2, like if 1 by 1 by 2, that becomes x to the power 2 times log 2x to the base x is equals to 4. This goes here, 2x whole square, x to the power log 2x whole square is 4x square to the base x is equals to 4. When bases are same, 4x square is equals to 4. 4 gets cancelled, x square is 1. So there you get x is equals to plus or minus 1. But friends, one thing, both can't be the solution part. You know why? Because if x is 1, base becomes 1, it should be excluded, and x is negative 1, here we have base in square roots, so that should also be excluded. So no solution for this. X equals to 5. Null set. Okay, good. Friend, like I want everyone to do this too. Same. By using all the properties of logarithms, you find it. If you're not going to get it, just inform me in the chat. I'll help you there. But please make sure you are going to get it. Okay. Next, find the product of the, another question, find the product of the roots of the equation. Very simple. See, very simple. See, you just try to understand. Suppose let x1 comma x2 are the roots of this equation. Okay. Product means log of x1 into x2. Okay. Now, if x1 comma x2 are the roots, what will be sum of the roots, friends? That means log x1 plus log x2. Na? This is an equation in logarithm, no? So, sum of the roots means this one. What do you mean by that? Sum of the roots minus b by a, that will be nothing but 2. Okay. Now, log a plus log b can be written as log x1 into x2 to the base 3 is equals to 2. So, x1 into x2 is equals to 3 power 2, which is equals to 9. Ho gaya? See, such an easy one, such an easy and interesting one. Nah? We didn't do anything here, right? They are asking us to product of the roots of the equation. If x1 comma x2 are the roots of the equation, x1 into x2 will be product of the roots. But we took simply sum of the roots we have taken. From there, we just, by using the properties of logarithm, we got it. That's it. Beautiful. Values of x. My dear friends, again, I am giving you this as homework. Please make sure you are doing it. Next, again, this all the equations. Only by using the properties of logarithm we are going to do. make sure that you are enough thorough with all the properties of logarithm. You will get it. You will get it. Next, logarithmic inequalities. Logarithmic inequalities, this plays major important role, friends. First thing, if base is known, if for known base, if base lie in between 0 to 1, reverse the inequality when you are converting it to exponential form. I mean, like suppose I have something like base less than 1, that means 0 to 1. If I have greater than in logarithm inequality, when you are converting into exponential, make sure you are changing the inequality, because whenever base is less than 1, you are supposed to change the sign of inequality. And coming to base is greater than 1, inequality remains same. That means this is what happens, like log x to the base a greater than p. If base is c less than, lying between 0 to 1, then the inequality has been changed. The inequality has been changed. Whereas if base is greater than 1, x will be greater than a to the power p. Next, same inequality sign has been changed. And log x to the base a, both sides logarithm, but same base less than 1, then inequality will be changed. X will be greater than y. Here inequality will be changed. Y will be greater than x. Okay. If base less than 1, inequality will be changed. If base greater than 1, there won't be any change in the inequality. There won't be any change in the inequality. We'll see this. See, a base is 7 clearly. Base is 7 clearly. But coming to one particular thing, first find the domain. Find the domain. Domain is very important. Finding the domain is very important, friends. What is this one? This 2x minus 6 whole divided by 2x minus 1 should be always greater than 0. Okay? Should be always greater than 0. That means x minus 3 divided by x minus 1 by 2 greater than 0. You know now, like taking inequalities already you know, friends. 1 by 2, this is 3. So greater than 0 means x belongs to minus infinity to 1 by 2. Open union 3 to infinity. This is what domain. You just keep it aside. Now think about it. Base is 7. There won't be any change in the sign of the inequality when you are going to convert into exponential form. Now, see, 2x minus 6 divided by 2x minus 1 greater than 7 to the power 0. 7 to the power 0 is 1. Na? So 2x minus 6 divided by 2x minus 1 it is. Get to the left hand side. Minus 1 greater than 0. Now simplify karo boss. 2x minus 6 minus 2x plus 1 whole divided by 2x minus 1 greater than 0. 2x gets cancelled. Minus 5 divided by 2x minus 1 greater than 0. As you have negative sign, multiply, that becomes 5 by 2x minus 1 is less than 0. That means 2x minus 1 is less than 0. Therefore, x belongs to minus infinity to 1 by 2. Now, once you get the solution, friends, the most important thing that I would like to tell you is, take the intersection of these two. Intersection of these two. If you just understand, minus infinity to 1 by 2 is the only solution that we get. This is the final. When you are getting, every solution has to be taken in common with the domain. So this is what the most important curious step in this particular problem. First find the domain, get the solution. Once you get the solution, make sure that you are taking whatever the solution that you are get, intersection of the given thing with the domain. That is what, friends. Now same again, here also base is 1 by 2. Here base is 1 by 2. So when you are going to first find domain, okay? First find domain. Keep this domain aside. Keep this domain aside. Now after finding domain, as the base is 1 by 2 which is less than 1, change the sign of the inequality. X square minus 5x plus 6. Now it is greater than less than 1 by 2 to the power minus 1. Less than, see, you understand one thing. I have changed the sign of the inequality. Okay, good. Now friends, I am giving you this particular problem as homework. After getting this solution, make sure the final solution and the domain solution, like this solution and domain, then only you will be getting the final solution. Clear? Is that clear? Good. Next, here same, base is 1 by 3. First get the domain, as same. Get the domain. Once you get the domain, next keep the domain aside. Here base is 1 by 3 na. You are supposed to change the inequality sign. That means 2 minus 3x by x less than or equals to, that becomes 1 by 3 minus 1. So after getting this solution, this intersection with the domain, you will be getting the final solution again. So this is also homework, boys, my dear girls, everyone, dear students, please make sure you are doing it thoroughly. Okay, same here again. First find the domain. Base is 2, so there won't be any change in the inequality sign. So same homework. This case is very important. Now the last case is if base is variable. Whenever the base is variable, friends, very important, you are supposed to take it in two cases. If base, like case 1, base lie in between 0 to 1. Case 2, base lie in between 1 to infinity. Okay? See? Simple. Like first find the domain. That is sure. Okay? What is domain, friends? Coming to domain, 4x minus 3 should be greater than 0. Should be greater than 0. So x greater than 3 by 4. X belongs to open 3 by 4 to infinity. This is the domain. Now case 1, we are supposed to split the whole problem into two cases. You know why? Because base is unknown. Base can be either less than 1 or greater than 1. If less than 1, one approach, greater than 1, one approach. For that you are supposed to split. First case 1. If base, what is the base that you got? Base is like x belongs to first case 0 to 1. Okay? In this case, when you are going to convert in terms of exponential form and base is lying between 0 to 1, the inequality sign changes. That is, hope the first step is clear, friends. Very, very important and simple. Base is unknown. You are supposed to splitting the whole problem into two cases. Case 1 is x belongs to, like the base belong to 0, 1. In that case, the inequality sign changes. So for now, everything to this side, 0 greater than or equals to x square minus 4x plus 3. That implies x square minus 4x plus 3. 0 is less than or equals to. That means this is greater than or equals to 0. So this can be factorized x minus 1 into x minus 3 greater than or equals to 0. That becomes here 1, here 3 greater than. So x belongs to minus infinity to 1 closed union closed 3 to infinity. We are not done. Wait, ruk karo. The thing is, now these two, like x belongs to 0, 1, no. But here, this should be taken intersection again. This should be taken intersection. What is the intersection of these two? Anyhow, x belongs to 0, 1. Okay, we are not done. Now, yes, this is case 1 solution. Now, go with case 2. Go with case 2. What is case 2? X greater than 1. In that case, what happens? There won't be any change in the inequality sign. Greater than or equals to x square. So that becomes x square minus 4x plus 3 less than or equals to 0. That means x minus 1 into x minus 3 less than or equals to 0. X belongs to closed 1, 3. Now again intersection these two. Again intersection of these two. What will be now? X belongs to open 1, 3 closed. Okay? We are done. This is second solution. We are not done now again. Now this is second solution. We are supposed to take the union of these two. Union. Whatever all the cases that we are getting, take the union. Now if you take x belongs to open 0 to 1, union, open 1 tooth, closed 3. We are not done again. Now the last thing which is very important, friends, is this one with our domain has to be taken intersection. Has to be taken intersection. Intersection of these two. Intersection of these two. That is what happens. So directly I guess like x belongs to from 3/4 to 3. This is our closed 3. I mean, this is the final solution, friends. I'll try to explain again. Very simple, my dear friends. Please do understand the basic part. When you don't know the base, first as usual find the domain. Okay. Next, split the base into two cases. That is, base belong to 0, 1. Second case, base belong to greater than 1. Now you'll be getting whatever the solution that you got, make sure that you're taking the intersection with the required one, because x has to be lie in this only, no? Okay, that you got. Case 1 final solution, case 2 final solution. Take the union of these two, all the cases union. After getting union of these cases, that should be intersection with the domain. So that will be our final solution, friends. Very simple. When base is unknown, split the whole problem into two cases. Clear, friends? I hope it is clear. So my dear best friends, in today's session, we had gone with this complete number system, polynomials. Yeah. In polynomials, we have seen remainder theorem, factor theorem. Then basic inequalities, we have seen modulus. In modulus, we have seen different like equations. In equations, we have seen logarithms, all the inequality problems, equality problems we have seen. My dear friends, I request everyone, I'm just reminding again that in this one shot, like I have covered everything, like whatever which is useful for objective part, I have covered everything. So this particular lecture is awesome, which is going to be awesome and helpful for everyone. Okay, whatever the problems that I have given for homework, please make sure you are putting efforts to do that. And my dear friends, if in the same way every lecture is being uploaded, which is going to be updated soon, if you are at the end of all these series, at the end of all these grade 11, 12, your confidence, your level of confidence is going to be increased. Awesome. So my dear friends, I request again, please make sure utilize this, and whatever the problems which are being asked for homework, you are doing it. If at all, if you're having any doubt, put it in the comment section. I'll help you. Take care, guys. See you in the next lecture. Bye bye.